Welcome to Milky Narratives. Take a deep breath, let the world grow quiet, and drift with me into the gentle mysteries of the cosmos. Tonight's journey begins among the stars. 1. The universe that remembers everything. Hook. Every star that shines tonight carries the memory of stars that died billions of years ago. The universe may never truly forget anything. It simply transforms every memory into something new. Close your eyes for just a moment and imagine looking up at the night sky thousands of years from now. The constellations may have shifted ever so slightly. New stars may have been born. Others may have quietly faded into darkness. Entire civilizations may have risen and disappeared between now and then. Yet one astonishing truth will remain unchanged. Every star that shines in that distant future will still carry traces of an unimaginably ancient past. Nothing the universe creates is ever entirely new. Every brilliant light overhead has inherited something from countless generations of stars that lived, transformed, and vanished long before our own sun was born. What if the universe has never truly forgotten anything? What if every planet, every galaxy, every atom inside your body is not simply matter arranged by chance, but a living archive of events stretching back almost 14 billion years? It is an extraordinary thought. We often imagine memory as something belonging only to minds. We remember childhood homes, familiar voices, or moments that quietly changed our lives forever. But perhaps memory exists in a much broader sense. Perhaps the universe remembers not with thoughts or emotions, but through transformation. Instead of storing its past inside a brain, it carries its history forward by constantly reshaping what already exists into something entirely new. Tonight, as you settle comfortably beneath the quiet sky, let us follow that remarkable idea. Imagine the very beginning of everything we can observe. The newborn universe was astonishingly simple. There were no stars decorating the darkness, no galaxies drifting across vast cosmic oceans, no planets circling distant suns, no forests, oceans, mountains, or living creatures wondering how they came to exist. There was only an expanding sea of energy, gradually cooling as space itself quietly stretched outward. At first glance, it might seem that such a simple beginning would leave little behind to remember. Yet, the opposite appears to be true. The earliest moments of cosmic history still echo throughout the universe today. Astronomers have discovered faint microwave radiation filling every direction in space. This ancient glow, often called the cosmic microwave background, began its journey nearly 14 billion years ago. It is sometimes described as the oldest light we can observe. Every radio telescope that studies this delicate radiation is not merely looking across space. It is looking backward through time, reading one of the oldest surviving chapters in the universe's history. The cosmos has preserved its earliest memories not inside books or monuments, but inside light itself. That ancient light has crossed billions of years without forgetting where it came from. As remarkable as that seems, it is only the beginning. Soon after the universe cooled enough for atoms to form, gravity quietly began gathering enormous clouds of hydrogen and helium. These clouds slowly collapsed under their own weight until pressure and temperature deep within them reached extraordinary levels. Then, almost like the striking of an invisible match, the first stars ignited. Those ancient stars lived lives entirely unlike our own. Some burned for millions of years. Others survived for billions. Inside each one, nuclear fusion carefully transformed simple hydrogen into increasingly complex elements. Helium became carbon. Carbon helped produce oxygen. Larger stars forged silicon, magnesium, sulfur, calcium, and countless other elements that had never existed before. Every new element became another memory written into the fabric of reality. Without those first generations of stars, the universe would have remained chemically simple forever. Instead, The cosmos quietly learned something remarkable. It learned how to build complexity from simplicity. Eventually, many of those ancient stars reached the ends of their lives. Some gently shed their outer layers into surrounding space. Others died in spectacular supernova explosions, briefly shining brighter than entire galaxies before scattering their contents across enormous distances. At first, such endings might appear tragic. Something beautiful had disappeared. A brilliant star had vanished forever. Yet the universe seemed to understand something that nature continues demonstrating again and again. Nothing truly disappears. It changes form. The expanding clouds left behind by dying stars became enormous reservoirs of enriched material. Within those drifting clouds rested carbon capable of forming organic chemistry, oxygen that would someday fill planetary atmospheres, iron destined for planetary cores, calcium waiting patiently to become bones, silicon that would one day form mountains, beaches, and perhaps even the tiny electronic circuits powering civilizations not yet imagined. The death of one generation quietly became the birth of another. Memory became creation. Our own sun belongs to this continuing story. Roughly 4.5 billion years ago, it formed inside one such cloud, already enriched by countless earlier stars. The swirling disk surrounding the newborn sun gradually assembled into planets. Tiny grains of dust collided. Small rocks became larger ones. Gravity patiently gathered scattered material into worlds. Earth itself emerged from ingredients carrying histories billions of years older than the planet they eventually formed. The iron beneath your feet once existed inside stars that disappeared long before the solar system existed. The oxygen you breathe has traveled through multiple generations of stellar evolution. Even the water flowing through rivers today contains hydrogen born shortly after the universe itself began. Every familiar object quietly carries an astonishing ancestry. Now consider something even more personal. Every atom inside your own body has participated in this extraordinary journey. The carbon forming your cells once drifted through the atmosphere of an ancient star. The calcium strengthening your bones was forged deep within stellar furnaces where temperatures exceeded millions of degrees. The oxygen entering your lungs every breath has likely circulated through oceans, forests, glaciers, clouds, and countless living creatures before reaching you. Nothing arrived here alone. Everything carries memories of earlier chapters. The famous phrase, "We are made of stardust," is far more than poetic language. It is a scientific description of our deepest physical origins. Yet perhaps the most beautiful part of this story is not simply that we inherited material from ancient stars. It is that the universe never stopped adding new chapters. Even today, somewhere within the Milky Way, enormous clouds continue collapsing into newborn stars. Around them, fresh planetary systems quietly begin assembling. Future worlds are forming at this very moment, using atoms that have already lived many previous lives. Some of those worlds may eventually develop oceans. Some may grow forests beneath unfamiliar skies. Some may never support life at all. Others may someday produce curious minds looking upward and wondering where they came from. If that happens, those future observers will discover exactly what we are discovering tonight, that nothing begins without inheriting something ancient. Perhaps memory itself is one of the universe's greatest creative forces. Not memory preserved through perfect stillness, but memory carried forward through endless transformation. A dying star becomes a newborn one. Ancient dust becomes living cells. Simple particles become conscious minds capable of reflecting upon their own origins. The story never repeats exactly, yet it never loses contact with what came before. Standing beneath the stars tonight, the sky begins to feel wonderfully different. Each point of light no longer appears isolated. Instead, every star becomes part of an enormous family tree, stretching backward across billions of years. Every galaxy becomes a library whose oldest chapters continue shaping every new page. And every quiet breath reminds us that we are not separate from this cosmic memory. We are among its newest expressions. Perhaps that is why the universe feels so timeless. It never clings to the past. It never erases it either. Instead, with extraordinary patience, it transforms every ending into another beginning, carrying every ancient memory gently forward into forms that could never have existed before, ensuring that nothing beautiful is ever truly lost, but simply rewritten into the next breathtaking chapter of an endless cosmic story. 2. Why the smallest things shape the largest. The fate of entire galaxies may depend upon particles so unimaginably tiny that billions could pass through your body every second without leaving the slightest trace. Imagine holding a single grain of sand between your fingers. It feels almost weightless, so small that a gentle breeze could easily carry it away. Now imagine shrinking that grain until it becomes smaller than the eye could ever hope to see, then smaller still. Eventually, you arrive at a world where atoms quietly dance, where particles appear and disappear, where invisible forces guide every interaction without ever announcing their presence. It is difficult to imagine that such unimaginably tiny things could influence anything truly enormous. Yet, perhaps the greatest surprise in all of science is this. The fate of entire galaxies may depend upon particles so unimaginably tiny that billions could pass through your body every second without leaving the slightest trace. The universe seems to delight in reminding us that size alone tells us very little about importance. Human intuition naturally focuses on the large. Towering mountains capture our attention. Great oceans inspire awe. Massive stars dominate the night sky. Galaxies stretching across hundreds of thousands of light years seem almost beyond imagination. When we think about shaping the universe, we instinctively picture enormous forces acting upon enormous objects. But reality quietly whispers another story. Some of the most powerful influences in existence come from scales so incredibly small that they remain forever invisible to ordinary experience. Consider the atom. For centuries, people believed matter could be divided forever into smaller and smaller pieces. Eventually, scientists discovered that every rock, every cloud, every tree, every ocean, and every living creature consists of unimaginably tiny atoms. Each one is almost entirely empty space. If an atom were enlarged until it became the size of a great cathedral, its nucleus would occupy only a tiny point near the center, while its electrons would exist as delicate clouds spread throughout the enormous interior. What appears solid to our hands is actually a magnificent illusion created by invisible forces. Even the chair supporting you now consists mostly of emptiness, carefully organized by nature. Already, the universe begins overturning our everyday expectations. The visible world depends upon structures too small to see. Yet atoms themselves are not the end of the story. Inside every atomic nucleus live even smaller particles. Protons and neutrons, once thought to be fundamental, are themselves composed of quarks bound together by extraordinarily powerful interactions. These particles are so tiny that comparing them to everyday objects almost becomes meaningless. Still, everything built from ordinary matter depends upon their remarkable stability. If the properties of these tiny particles were only slightly different, atoms might never have formed. Chemistry would disappear. Stars could never shine. Life would never awaken. The largest structures in the cosmos quietly depend upon relationships unfolding at the smallest imaginable scales. One of nature's greatest achievements lies in maintaining this astonishing balance. 4 fundamental forces govern every known interaction throughout the universe. Gravity gently gathers galaxies together. Electromagnetism shapes atoms, molecules, light, and chemistry. The strong nuclear force binds atomic nuclei. The weak nuclear force quietly allows certain particles to transform into others, making stellar fusion possible. Each force operates according to precise rules. Each becomes essential. Remove even one, and reality itself changes beyond recognition. Imagine an orchestra preparing to perform a magnificent symphony. Thousands of notes will soon fill the concert hall. Yet, if a single instrument quietly falls out of tune, the entire performance changes. The smallest adjustment can ripple outward through everything that follows. The universe seems to operate with similar elegance. Its grandest masterpieces emerge because countless tiny interactions remain beautifully coordinated. Perhaps nowhere is this more evident than inside the hearts of stars. Deep within our sun, hydrogen nuclei collide under extraordinary temperatures and pressures. Most collisions accomplish nothing. The particles simply bounce apart. But every so often, through processes governed by quantum physics and the weak nuclear force, one tiny transformation occurs. Hydrogen begins becoming helium. That single microscopic event releases energy. Multiply it by unimaginable numbers occurring every second, and an entire star begins shining. The warmth reaching your skin on a sunny afternoon originates from interactions smaller than any microscope could ever directly observe. The brightness of the sky begins with invisible events unfolding inside individual atomic nuclei. Even light itself tells a similar story. Every photon crossing space carries energy without possessing mass. Tiny packets of electromagnetic radiation leave distant stars and travel for years, centuries, or even billions of years before finally reaching your eyes. A single photon is astonishingly small, yet countless photons together illuminate galaxies. The visible universe reveals itself because innumerable tiny messengers quietly cross the darkness. Without them, the cosmos would remain hidden forever. Some particles become even more mysterious. At this very moment, trillions upon trillions of neutrinos pass effortlessly through your body every second. Most originated inside the sun. Others were created during ancient supernova explosions. Still others emerged shortly after the Big Bang itself. Neutrinos interact so weakly with ordinary matter that almost all pass straight through entire planets without interruption. You never feel them, you never notice them, yet they continuously stream through every living creature on Earth. Invisible visitors from the deepest reaches of cosmic history quietly accompany every moment of our lives. For decades, scientists struggled even to detect these elusive particles. Today, enormous underground observatories filled with ultra-pure water patiently wait for the rare occasions when a neutrino briefly reveals its presence. Such discoveries remind us that reality often contains far more than our senses alone can perceive. The universe is vastly richer than appearances suggest. Dark matter deepens this mystery even further. Astronomers now believe that ordinary matter represents only a small fraction of everything that exists. The rest appears to consist of invisible matter, whose particles have not yet been directly identified. Although we cannot see them, their gravity quietly shapes galaxies, clusters of galaxies, and the enormous web-like structure stretching across the observable universe. Entire galaxies owe their existence to particles humanity has never directly observed. Again, the smallest influences quietly govern the largest outcomes. This remarkable principle extends beyond astronomy. Life itself depends upon molecular interactions unfolding continuously inside every cell. DNA stores information through tiny chemical arrangements. Proteins fold into intricate shapes determined by atomic forces. Neurons communicate using microscopic exchanges of charged particles. Your thoughts, memories, emotions, and dreams all emerge from countless events occurring at scales far smaller than human perception. The grandeur of consciousness begins with extraordinary precision among the smallest building blocks of matter. Nature repeatedly teaches the same gentle lesson. Importance does not belong exclusively to what is large. Sometimes the quietest foundations support the greatest achievements. A towering forest depends upon invisible microorganisms enriching the soil. An enormous whale begins as a single fertilized cell. A magnificent galaxy depends upon particles drifting through ancient space billions of years earlier. Everything vast rests upon something remarkably small. There is something profoundly comforting about this realization. Our own actions often resemble those tiny particles. A kind word may seem insignificant. One thoughtful conversation, one moment of patience, one quiet act of generosity. Individually, they appear almost invisible against the enormous scale of history. Yet over time, they ripple outward through families, communities, generations, and lives we may never even meet. Perhaps the universe has always worked this way. Great transformations rarely begin with dramatic explosions alone. More often, they begin with countless tiny events quietly accumulating until something entirely new emerges. Standing beneath the night sky tonight, the stars begin to feel slightly different. Their brilliance no longer belongs only to immense distances and colossal sizes. Instead, each star becomes a reminder that the largest wonders in existence owe everything to invisible processes unfolding among the smallest pieces of reality. The galaxies above us, the planets beneath our feet, the breath filling our lungs, the thoughts moving gently through our minds. All of them emerge because unimaginably tiny particles have spent billions of years quietly following the elegant laws of nature with unwavering consistency. Perhaps that is one of the universe's most beautiful secrets. Its greatest masterpieces are never built only from what is grand. They are patiently woven together from countless invisible moments, each so small it almost escapes notice, yet together powerful enough to shape stars, galaxies, life itself, and every future chapter the cosmos has yet to write. 3. The silent language of the cosmos. The universe has never spoken with words, yet every ray of light, every ripple in space, and every orbiting world carries messages waiting patiently to be understood. If these quiet journeys through the hidden language of the cosmos help you relax and discover new wonders before sleep, consider subscribing and joining us for many more peaceful explorations beneath the stars. Have you ever wondered how the universe speaks? Not with voices, not with written symbols, not with songs carried upon the wind. And yet, everywhere we look, messages quietly travel across the cosmos. A beam of light leaving a distant galaxy, a planet circling its silent star, a faint ripple passing through the very fabric of space. The universe has never spoken with words, yet every ray of light, every ripple in space, and every orbiting world carries messages waiting patiently to be understood. Perhaps the greatest achievement of science has never been forcing nature to reveal its secrets. Perhaps it has simply been learning how to listen. For most of human history, the night sky appeared silent. Stars rose each evening. The moon changed its shape. Planets wandered among the constellations. Everything seemed beautiful, mysterious, and strangely unreachable. Ancient civilizations watched these motions with extraordinary care. Without realizing it, they had already begun reading the universe's first language, patterns. Even before telescopes existed, people noticed that certain stars always returned with the changing seasons. The appearance of particular constellations announced the coming of spring. Others marked the arrival of winter. The heavens became an enormous calendar written entirely with light. Nature was already speaking. Humanity simply learned how to recognize its rhythm. As centuries passed, our ability to listen slowly improved. Galileo raised his telescope toward Jupiter and discovered 4 tiny moons orbiting the giant planet. The universe had not changed overnight. Those moons had always been there. The message had always existed. Only the listener had changed. That quiet lesson continues today. Every improvement in our instruments teaches us that reality has always been communicating far more than we previously realized. Perhaps light is the universe's oldest language. Every photon carries information about where it came from. Its color reveals temperature. Its direction tells us location. Its intensity speaks of distance. Its spectrum preserves chemical fingerprints that no star can hide. When astronomers observe sunlight passing through a prism, it separates into countless colors. Dark lines appear within that rainbow. Each one corresponds to a specific element, absorbing particular wavelengths. Hydrogen leaves its signature. Helium writes another. Calcium, oxygen, sodium, carbon, iron, and dozens of others quietly announce their presence. A star never introduces itself by name. Instead, it allows its light to tell its story. Without ever touching a distant sun, scientists can determine its temperature, its age, its chemical composition, its motion, and even whether planets quietly circle around it. The universe speaks through light with astonishing honesty. It cannot easily conceal its history. Even color becomes part of this remarkable language. Young, massive stars often shine with brilliant blue-white light because their surfaces burn at extraordinary temperatures. Older, cooler stars glow orange or red. Entire galaxies reveal their histories through subtle shifts in color. Astronomers need only observe carefully, and the cosmos begins describing itself. A patient observer becomes fluent in conversations billions of years old. Distance itself leaves another message. Because light travels at a finite speed, looking farther into space also means looking farther into the past. The moon appears as it existed just over 1 second ago. Sunlight reaching Earth departed roughly 8 minutes earlier. The nearest stars appear as they were years ago. The most distant galaxies reveal themselves as they existed billions of years before our solar system even formed. Every telescope becomes something extraordinary, not merely a machine for seeing, a machine for reading time. The deeper we look into space, the older the story becomes. It is as though the universe has carefully preserved every chapter instead of allowing them to disappear forever. Yet light is only one voice within this enormous conversation. Gravity speaks as well. For centuries, gravity seemed silent, invisible, obedient only to mathematical equations. Then, in the 21st century, humanity learned to hear something entirely new: gravitational waves. When enormous objects, such as black holes or neutron stars, collide, they create tiny ripples traveling through space-time itself. By the time these ripples reach Earth, they are unimaginably small. They stretch and compress distances by less than the width of an atomic nucleus. Detecting them required instruments of astonishing precision. When scientists finally succeeded, it marked one of history's greatest moments of listening. For the first time, humanity heard the universe through gravity instead of light. It was not sound in the ordinary sense, yet the signals could be translated into gentle chirps whose rising tones reflected black holes spiraling together before merging into one. After billions of years crossing the universe, those ancient ripples finally arrived. Another language had quietly revealed itself. Even planets communicate, not intentionally, simply through their motion. When astronomers observe a distant star gently wobbling back and forth, they know an unseen planet must be pulling upon it. Sometimes, a planet passes directly in front of its star, causing the brightness to dim ever so slightly. Those tiny changes allow scientists to calculate the planet's size, orbit, and even hints about its atmosphere. Again, the universe offers information freely. We simply need enough patience to recognize the pattern. Comets tell stories as well. Many preserve frozen material left over from the birth of the solar system. They become wandering messengers from an era before Earth possessed oceans or continents. Meteorites carry minerals older than our planet itself. Each one becomes a fragment of history delivered across millions of miles. Even the rocks beneath our feet quietly participate in the conversation. Nature remembers. Nature communicates. Nothing remains completely silent. The cosmic microwave background may be the oldest message of all. This faint glow fills every direction in space. It originated when the universe itself was only a few 100,000 years old. Although invisible to human eyes, sensitive instruments reveal delicate patterns spread across the sky. Those tiny fluctuations eventually became galaxies, stars, planets, and every living creature. The oldest light continues whispering the story of the beginning. Remarkably, the message never stopped traveling. It simply waited until intelligent observers finally learned how to detect it. Perhaps this is the true beauty of science. It is not the invention of nature's language. It is the gradual discovery that the language has always surrounded us. The universe never became more expressive. Humanity became better listeners. There is something deeply comforting about this idea. The cosmos does not shout. It does not demand attention. Its communication is astonishingly gentle. A faint beam of light crossing billions of years, a subtle gravitational ripple, a tiny shift in a distant star's brightness. Almost every great discovery begins not with noise, but with careful observation. Perhaps our own lives contain similar lessons. The most meaningful conversations are not always the loudest ones. A quiet glance, a patient silence, a familiar smile. Sometimes understanding grows through the smallest signals. Nature seems to follow the same principle. Its deepest truths often arrive softly. Standing beneath the stars tonight, the sky no longer appears silent. Every point of light becomes a messenger. Every constellation carries history. Every distant galaxy sends ancient letters across the darkness. Space itself hums with information, waiting patiently for curious minds. And perhaps the most remarkable realization is this: the universe has never hidden its story from us. Since the first light began traveling across expanding space, it has been speaking continuously. Generation after generation has simply learned one more word, one more sentence, one more beautiful chapter of a language so vast that no civilization will ever finish reading it completely. If these quiet journeys through the hidden language of the cosmos help you relax and discover new wonders before sleep, consider subscribing and joining us for many more peaceful explorations beneath the stars. 4. When empty space is never truly empty. What appears to be perfect emptiness may actually be one of the busiest places in existence, where invisible activity quietly shapes everything that can ever exist. Take a deep breath and imagine drifting into the vast emptiness between the stars. No planets, no glowing nebulae, no brilliant suns filling the darkness, only endless space stretching farther than imagination can follow. At first glance, it seems completely empty, a perfect vacuum, a place where absolutely nothing exists. For centuries, this appeared to be one of the simplest parts of the universe. Surely, if there were anywhere that contained nothing at all, it would be the immense darkness separating galaxies. Yet modern physics has quietly revealed something astonishing. What appears to be perfect emptiness may actually be one of the busiest places in existence, where invisible activity quietly shapes everything that can ever exist. The universe has a remarkable habit of overturning our deepest assumptions. Things that appear solid are mostly empty space. Objects that seem motionless are filled with restless atoms. Light behaves both like particles and waves. And empty space itself may not be empty at all. Instead, it may be alive with invisible processes unfolding every instant. This realization did not arrive all at once. It emerged gradually as generations of scientists asked increasingly careful questions about the nature of reality. What exactly is space? Is it simply the absence of matter? Or does it possess properties of its own? For a long time, empty space was treated almost like the blank paper surrounding words inside a book. The paper allowed the story to exist, but it played no role in the story itself. Space appeared to be merely the stage upon which planets moved and stars burned. Then, during the 20th century, that comfortable picture began to change. Albert Einstein showed that space and time are not passive backgrounds. Together they form space-time, an extraordinary fabric capable of bending, stretching, and responding to mass and energy. The presence of a star changes the geometry around it. A black hole curves space-time so dramatically that even light struggles to escape. Galaxies move not because they are pulled through empty nothingness, but because space-time itself quietly guides their paths. The stage had suddenly become one of the actors. Space itself possessed structure. Yet the surprises continued. Quantum physics invited scientists to examine emptiness at even smaller scales. There they discovered something almost impossible to picture. According to quantum theory, complete stillness may never truly exist. Even the emptiest region imaginable cannot remain perfectly quiet. Instead, tiny fluctuations constantly appear and disappear within unimaginably brief moments. These events happen so quickly that they escape ordinary observation. Particles briefly emerge. Their corresponding antiparticles appear alongside them. Almost immediately, they meet again, canceling one another before either can travel very far. The process repeats endlessly. To our senses, nothing seems to happen. Yet, beneath that apparent calm, reality remains astonishingly active. Physicists sometimes describe this as the quantum vacuum. Although the word vacuum suggests emptiness, it behaves more like an ocean whose surface appears peaceful while invisible currents constantly move beneath. No wave remains forever. No disturbance lasts long, but the motion never entirely stops. The universe refuses to become perfectly silent. Imagine standing beside a still lake before sunrise. The water appears smooth from a distance, yet if you look closely, tiny ripples spread across its surface. Insects touch the water. Fish disturb it from below. Gentle breezes create nearly invisible patterns. The lake never truly rests. Space itself may resemble that quiet morning lake. Its apparent emptiness conceals extraordinary activity occurring beyond ordinary perception. This restless nature of empty space has measurable consequences. One remarkable example involves something called the Casimir effect. When two extremely smooth metal plates are placed incredibly close together in a vacuum, they experience a tiny force pushing them toward one another. Nothing visible lies between them. No wind blows. No magnetic attraction explains the movement. Instead, quantum fluctuations surrounding the plates produce a subtle difference in pressure. Even empty space exerts influence. The vacuum itself becomes physically real. Experiments have repeatedly confirmed this surprising prediction. Emptiness can gently push. There is something wonderfully poetic about that. What seems to contain nothing may quietly possess enormous importance. Perhaps the universe has always been reminding us not to judge reality solely by appearances. Some of its greatest mysteries hide where we least expect them. Even light depends upon this remarkable emptiness. Photons travel across billions of light years through regions almost devoid of ordinary matter. Without space, light could not carry messages from ancient galaxies. The oldest stories in the cosmos would never reach us. Every beautiful night, sky depends upon emptiness, serving as an almost perfect pathway. Far from being useless, the vast darkness between stars allows the universe to communicate across unimaginable distances. Gravity also requires this remarkable arena. When two galaxies slowly drift toward one another, the invisible geometry of space-time quietly determines their motion. Mass bends space. Space guides motion. The relationship continues endlessly. Neither can be fully understood without the other. Again, emptiness reveals itself as something far richer than absence alone. Perhaps one of the greatest mysteries of modern cosmology also emerges from empty space. Astronomers have discovered that the expansion of the universe is accelerating. Galaxies are not merely moving apart. Their separation appears to increase faster and faster over time. To explain this astonishing observation, scientists introduced the idea of dark energy. Although its true nature remains unknown, dark energy may be deeply connected to the properties of space itself. The emptiness filling the universe could contain energy that quietly influences the evolution of the entire cosmos. Imagine that. The greatest large-scale behavior of the observable universe may depend upon something hidden within empty space. What appears least important may actually shape everything else. This theme appears again and again throughout nature. Invisible air allows birds to fly. Transparent water supports entire ecosystems. Space between atoms gives matter its structure. Silence gives music its beauty. Pauses allow conversations to breathe. Absence itself often creates possibility. The universe seems remarkably skilled at transforming emptiness into opportunity. Even our own existence reflects this principle. The atoms forming your body consist mostly of empty space. If every atom were compressed until its nucleus touched the next, all the matter inside every human being would occupy only an astonishingly tiny volume. The solidity we experience arises from invisible forces rather than densely packed material. You are, in one sense, wonderfully spacious. Yet, that spaciousness does not diminish your reality. It makes your existence possible. Perhaps this invites a quieter way of seeing the cosmos. Instead of imagining empty space as lifeless nothingness, we may begin seeing it as fertile possibility. A place where light travels, where gravity acts, where quantum fields gently fluctuate, where galaxies drift, where future stars slowly gather from diffuse clouds, where the next chapter of cosmic history patiently prepares itself long before anyone notices. Standing beneath the night sky now, the darkness between stars no longer appears empty. It becomes filled with hidden activity. Invisible fields stretch across unimaginable distances. Ancient photons quietly cross expanding space. Quantum fluctuations dance beyond perception. Gravity patiently shapes entire clusters of galaxies. The silence itself becomes astonishingly alive. Perhaps that is one of the most beautiful lessons the universe offers. Reality is often richest where our eyes see the least. The greatest activity may unfold where everything appears perfectly still. The deepest foundations may hide beneath apparent emptiness. And every peaceful patch of darkness overhead quietly reminds us that the universe has never required constant brightness to create extraordinary wonders. Sometimes, its greatest masterpieces begin within silence, unfold inside invisibility, and patiently emerge from spaces that once seemed to contain absolutely nothing at all. 5. The universe's endless web of cause and effect. Nothing in the cosmos happens alone. Every event, from the birth of a single atom to the collision of entire galaxies, quietly becomes the beginning of countless new stories. Imagine watching the first domino fall. It touches the next, then another. Soon, an entire chain begins moving, each piece transferring its motion to the one that follows. What first appeared to be a single small event gradually reveals itself as part of something far larger. The final domino falls only because every previous one completed its own quiet task with perfect patience. Now, imagine that chain extending not across a table, but across billions of years. Stretch it through galaxies, through stars, through planets, through every living creature that has ever existed. Perhaps the universe itself is one endless sequence of beginnings, giving rise to other beginnings. Nothing in the cosmos happens alone. Every event, from the birth of a single atom to the collision of entire galaxies, quietly becomes the beginning of countless new stories. One of the deepest lessons nature offers is that isolation is almost an illusion. We often describe events as though they happen independently. A star explodes, a planet forms, a comet passes by, a forest grows. Yet every one of those events carries an ancestry stretching unimaginably far into the past, while simultaneously sending consequences forward into futures that may never fully end. The universe seems to think not in isolated moments, but in relationships. Every cause quietly becomes another effect. Every ending becomes another beginning. Every answer gives birth to another question. Consider something as seemingly simple as a single atom of carbon. It did not simply appear one day. Its story began inside the heart of a massive star where unimaginable temperatures allowed lighter elements to fuse into heavier ones. That star itself formed because gravity slowly gathered enormous clouds of hydrogen left behind by an even earlier generation of stars. Those clouds existed because the expanding universe cooled after the Big Bang. The Big Bang itself created the hydrogen that would one day become everything else. Long before that carbon atom became part of your body, it had already participated in a history spanning billions of years. Yet the story did not end when it reached you. Perhaps tomorrow, it will become part of a leaf. Centuries later, it may drift into the atmosphere. Millions of years from now, it could become locked inside ancient rock before eventually returning to space when our sun reaches the final stages of its life. One atom quietly connects countless chapters that appear completely unrelated when viewed separately. Nature constantly reminds us that time is less like a collection of disconnected moments and more like an endlessly flowing river. Every drop influences those that follow. Stars demonstrate this beautifully. When a massive star reaches the end of its life, it does not simply disappear. Its spectacular explosion enriches surrounding space with newly forged elements. Shockwaves spread outward, compressing nearby clouds of gas. Those clouds begin collapsing. New stars ignite. New planets emerge. Perhaps somewhere among those newborn worlds, life eventually awakens. Without the original explosion, none of those future possibilities could exist. A stellar death becomes a cosmic birth announcement. The universe wastes nothing because every consequence quietly prepares another opportunity. Even galaxies participate in this endless conversation. From a distance, they appear serene, slowly rotating through space with graceful elegance. Yet, over immense spans of time, galaxies frequently encounter one another. Gravity draws them together. They begin an intricate dance lasting hundreds of millions of years. Spiral arms stretch outward. Enormous clouds collide. Fresh waves of star formation ignite. Eventually, two galaxies merge into one. What first appears to be destruction often becomes extraordinary renewal. The Milky Way itself carries evidence of countless ancient mergers. Our galaxy is not a perfectly preserved original. It is the result of many earlier encounters whose effects continue shaping the night sky we admire today. Even our own solar system owes its existence to an astonishing chain of earlier events. The Sun formed because earlier stars lived and died. Earth assembled because gravity patiently gathered leftover materials surrounding the young Sun. The Moon likely formed after a tremendous collision between the early Earth and another planetary body. That impact altered Earth's rotation. It stabilized our planet's tilt. It influenced tides. Those tides affected coastlines. Coastlines helped shape environments where early life may have flourished. A single collision billions of years ago continues influencing every ocean wave reaching the shore today. Nature rarely allows consequences to end where they begin. Life itself emerged through countless interconnected steps. Simple molecules combined into more complex chemistry. Some developed the ability to store information. Others learned to reproduce. Natural selection gradually favored tiny improvements accumulated across unimaginable spans of time. No single moment suddenly created life. Instead, every successful change quietly prepared the conditions for another. Evolution resembles an endless conversation rather than a sudden invention. Each generation inherits the achievements of countless earlier generations while adding something new for those that follow. Human civilization follows the same pattern. Every discovery depends upon earlier discoveries. The invention of writing preserved knowledge. Mathematics expanded understanding. Astronomy inspired navigation. Navigation connected civilizations. Shared ideas accelerated innovation. Electricity transformed communication. Computers expanded scientific research. Modern telescopes now allow us to study galaxies billions of light years away. Each achievement rests upon thousands of earlier contributions made by people who could never have imagined where their work would eventually lead. History itself behaves like the universe. Every chapter quietly prepares the next. Even light participates in this magnificent chain. A photon leaving a distant star begins an extraordinary journey. It may travel across millions or billions of years before finally entering a telescope on Earth. That tiny interaction allows astronomers to measure distance, temperature, chemical composition, and motion. Those measurements inspire new theories. Theories lead to better instruments. Better instruments reveal deeper mysteries. One photon becomes part of humanity's growing understanding of reality. Its journey continues long after leaving its original star. There is something deeply comforting about recognizing this endless web of connections. Sometimes our individual lives feel surprisingly small. We wonder whether our choices truly matter against the immense scale of cosmic history. Yet the universe gently suggests another perspective. Great transformations rarely emerge from isolated miracles. Instead, they grow from countless small influences patiently building upon one another. A single seed becomes a forest. One conversation changes another person's life. A curious child grows into a scientist whose discoveries reshape humanity's understanding of the cosmos. No one can predict how far the consequences of a quiet moment may eventually travel. Nature has always embraced this beautiful uncertainty. Chaos theory offers another fascinating glimpse into interconnectedness. Certain complex systems prove extraordinarily sensitive to tiny changes. A minute difference at the beginning may eventually produce dramatically different outcomes. Although popular culture often exaggerates the famous butterfly effect, the underlying principle remains profound. The future sometimes depends upon details almost too small to notice. Again, the universe reminds us that relationships matter more than appearances. What seems insignificant today may quietly influence tomorrow in ways no observer could fully anticipate. Perhaps this explains why the cosmos feels so alive. Not because it possesses intention in the human sense, but because everything continually responds to everything else. Gravity links stars. Light connects galaxies. Chemistry builds life. Life develops intelligence. Intelligence studies the universe. The universe gradually becomes aware of itself through minds formed from its own ancient matter. The circle continues expanding. Standing beneath the stars tonight, it becomes almost impossible to point toward anything truly separate. The air entering your lungs was once part of distant oceans, ancient forests, and forgotten civilizations. The calcium inside your bones formed within long-vanished stars. The photons reaching your eyes began their journey before human history was written. Even your thoughts arise from countless experiences accumulated throughout your lifetime. Everything belongs to an enormous network of relationships stretching across both space and time. Perhaps this endless web is one of the universe's quietest masterpieces. Nothing exists only for itself. Nothing ends entirely with its own conclusion. Every event becomes a bridge connecting countless earlier stories to countless future ones. The cosmos continues weaving these invisible threads with extraordinary patience, ensuring that every atom, every star, every galaxy, every living creature, and every curious mind becomes both the consequence of ancient beginnings and the gentle cause of wonders still waiting to unfold beneath skies that future generations have yet to see. 6. The gentle patience of cosmic time. The universe never seems concerned with rushing toward the future. Given enough time, even the most extraordinary transformations unfold with breathtaking calm. Imagine planting the seed of a giant oak tree. Tomorrow, nothing seems different. A week later, the soil still appears almost unchanged. Months pass before the first delicate shoot greets the sunlight. Even after many years, the tree is still only beginning the long journey toward the towering giant it may someday become. Nature never apologizes for moving slowly. It never worries about arriving late. It understands something that modern life often forgets. The greatest transformations are almost always invisible while they are happening. The universe never seems concerned with rushing toward the future. Given enough time, even the most extraordinary transformations unfold with breathtaking calm. Perhaps nowhere is patience more beautifully displayed than in the history of the cosmos itself. Today, we often speak about the Big Bang as though it were a dramatic explosion that instantly created everything we know. The phrase itself almost encourages that image: a sudden beginning, a burst of unimaginable energy, a universe appearing all at once. Yet, the reality is both more subtle and more astonishing. The earliest moments certainly unfolded with extraordinary speed, but the universe did not immediately become rich with stars, planets, and life. Instead, it entered a process that continues even now: expansion, cooling, organization, transformation. Each stage patiently prepared the conditions for the next. The universe never skipped ahead. It never hurried toward complexity. It simply allowed time to perform one of its quietest miracles. Consider the first stars. After the universe became transparent, hundreds of millions of years passed before gravity slowly gathered enough hydrogen to ignite the earliest stellar fires. Hundreds of millions of years. Human history, from the first cities until today, occupies only a tiny fraction of that interval. To us, such a span feels almost impossible to imagine. Yet the universe appeared perfectly content to wait. Gravity did not complain. Hydrogen did not become impatient. The laws of physics quietly continued their work until the necessary conditions finally arrived. Only then did the first stars begin shining. Their patience became the beginning of cosmic illumination. Those first stars themselves required time to complete their own remarkable journeys. Some lived only a few million years. Others endured much longer. Inside their glowing interiors, nuclear fusion slowly transformed simple hydrogen into heavier elements. Carbon was not created instantly. Oxygen emerged gradually. Iron required still more time. Every element that would someday become mountains, oceans, forests, and living creatures formed through countless tiny reactions repeated over unimaginable ages. The atoms inside your body are monuments to extraordinary patience. Nature never rushed their creation. Even galaxies demonstrate this remarkable calm. From our perspective, galaxies seem timeless. Elegant spirals quietly turning through darkness. Majestic collections of billions of stars. Yet every galaxy is constantly changing. Stars are born. Others quietly disappear. Clouds of gas drift through enormous distances. Spiral arms slowly evolve. Black holes influence surrounding regions. Neighboring galaxies gradually approach one another across millions of light years. Nothing stands still. The motion simply unfolds so slowly that human lifetimes rarely notice it. If we could watch a galaxy over billions of years, it would resemble an immense flower opening in extraordinarily slow motion. Patience reveals beauty invisible to hurried observers. Our own Milky Way provides a remarkable example. It rotates only once every 230 million years or so. When dinosaurs walked across Earth, our solar system occupied an entirely different position within the galaxy. Since their extinction, the Sun has completed only a small portion of another orbit around the galactic center. Human civilization has not witnessed even one complete galactic year. We often imagine ourselves living through dramatic change. Compared with the rhythms of galaxies, however, our entire recorded history resembles the briefest heartbeat. Yet the universe loses nothing by moving slowly. Its calm allows magnificent structures to emerge. Planetary systems also reveal this quiet rhythm. When our solar system formed, it did not instantly produce stable worlds. Tiny particles first collided within a swirling disk surrounding the newborn sun. Grains of dust became pebbles. Pebbles merged into rocks. Rocks gradually assembled into mountain-sized bodies. Those larger objects continued colliding until planets slowly emerged. Every impact altered future possibilities. Every orbit became slightly more stable. Millions upon millions of years quietly passed before Earth resembled anything familiar. Even then, the journey had barely begun. The young Earth remained extraordinarily hostile. Volcanoes erupted constantly. Asteroids frequently struck its surface. The atmosphere differed greatly from today's. Oceans slowly condensed as the planet cooled. Chemical cycles gradually established themselves. Only after immense spans of time did conditions become suitable for the earliest forms of life. Again, the universe displayed remarkable patience. Nothing appeared before its foundations were ready. Life itself became, perhaps, the greatest demonstration of slow creation. The earliest organisms remained astonishingly simple for billions of years. Single cells quietly dominated Earth, while continents drifted across the planet. Photosynthetic bacteria slowly transformed the atmosphere by releasing oxygen. This process alone required hundreds of millions of years. No sudden miracle occurred. Tiny organisms patiently changed the chemistry of an entire world. Eventually, more complex cells emerged. Then multicellular life, then fish, forests, dinosaurs, mammals, humans. Every step depended upon countless earlier steps patiently unfolding before it. Evolution never rushed. It simply continued. There is something deeply reassuring about this pattern. Modern life often celebrates speed, faster communication, faster travel, instant information, immediate results. We grow accustomed to expecting change within moments. The universe quietly offers another perspective. Some achievements cannot be hurried. Stars cannot be rushed into existence. Mountains cannot instantly rise. Forests cannot mature overnight. Wisdom itself often grows much like galaxies do, slowly, steadily, layer upon layer. Perhaps this is why cosmic history feels strangely peaceful. Nothing competes. Nothing panics. Gravity never fears running out of time. The stars never worry about tomorrow's schedule. Nature simply follows its laws with extraordinary confidence. Given sufficient time, remarkable things become possible. Even erosion tells this story beautifully. A river appears gentle. Its water slips quietly over smooth stones. One afternoon beside its banks reveals almost no visible change. Yet over millions of years, that same river carves immense valleys through solid rock. The Grand Canyon did not emerge through violence alone. Patience shaped it. Small movements, repeated endlessly, became magnificent transformation. The universe seems remarkably fond of this method. Tiny changes, repeated consistently, across immense spans of time, eventually creating wonders beyond imagination. Perhaps human understanding develops similarly. Each generation contributes only a little. One observation, one experiment, one new question, one improved idea. Alone, each achievement appears modest. Together, they gradually transform humanity's understanding of reality. Science itself grows patiently. Knowledge resembles a forest more than a building. Each generation plants trees whose full shade may comfort people not yet born. Standing beneath the stars tonight, it becomes easier to appreciate this extraordinary calm. The light arriving from distant suns has traveled for years without haste. Galaxies continue evolving, whether anyone watches them or not. Nebulae quietly prepare future stars. Planets patiently circle their suns. The universe never measures success by speed. It measures success by possibility. Given enough time, hydrogen becomes stars. Stars become heavy elements. Heavy elements become planets. Planets become living worlds. Living worlds become curious minds capable of wondering how everything began. Perhaps that is the quiet genius of cosmic time. It never demands perfection immediately. It simply offers endless opportunities for simple beginnings to become extraordinary endings, allowing every beautiful transformation to unfold at exactly the pace required by the timeless patience that has guided the universe since its very first moments, and will likely continue guiding it long after countless future generations have looked upward with the same quiet sense of wonder. 7. Why mystery may never disappear. Every generation believes it has illuminated a little more of reality, yet every new light seems only to reveal how much larger the surrounding darkness truly is. If these gentle reflections help you drift peacefully through the mysteries of science and the universe, don't forget to subscribe so we can continue exploring together on future nights beneath the stars. For thousands of years, humanity has looked toward the heavens, believing that the next great discovery might finally explain everything. Every generation has imagined itself standing near the end of the journey. The ancient philosophers believed the stars were fixed upon perfect celestial spheres. Later, astronomers imagined that our own galaxy contained nearly the entire universe. Physicists once hoped that a handful of elegant equations might eventually describe every force in nature. Again and again, each new era felt as though it stood just one step away from complete understanding. And yet something remarkable always happened. Every answer opened another question. Every solved mystery quietly uncovered an even larger one waiting just beyond it. Perhaps this is the universe's most beautiful habit. Every generation believes it has illuminated a little more of reality, yet every new light seems only to reveal how much larger the surrounding darkness truly is. Imagine walking through an enormous cave with only a small lantern. At first, your light reveals a tiny circle around your feet. As your lantern grows brighter, you expect the darkness to retreat. It does. You see farther than before, but something unexpected also happens. The edge where light meets darkness becomes much larger. Instead of eliminating mystery, greater understanding expands the boundary between what is known and what remains unknown. Knowledge does not simply replace ignorance, it enlarges the horizon where curiosity lives. The history of science has unfolded in much the same way. When Isaac Newton described gravity with extraordinary mathematical precision, it seemed as though one of nature's greatest secrets had finally been solved. His equations explained the motions of falling apples, orbiting moons, and wandering planets with astonishing accuracy. For more than 2 centuries, Newton's vision transformed humanity's understanding of the cosmos. Yet eventually, careful observations revealed tiny discrepancies. Mercury's orbit refused to behave exactly as expected. Light itself appeared to possess strange properties that classical physics struggled to explain. Rather than ending the search, Newton's triumph quietly prepared the way for Albert Einstein. Einstein's theory of general relativity revealed that gravity is not simply a force pulling objects together. Instead, massive objects curve space-time itself. It was one of the greatest intellectual revolutions in history. Again, humanity celebrated. Again, it seemed another profound mystery had finally yielded its answer. Yet Einstein's magnificent theory soon encountered mysteries of its own. General relativity beautifully explains the motions of planets, stars, and galaxies. Quantum mechanics describes the astonishing behavior of atoms and subatomic particles with equal brilliance. Individually, both theories work extraordinarily well. Together, however, they refuse to fit comfortably into a single picture. The two greatest pillars of modern physics still resist complete unification. The deeper we explore, the more reality reminds us that its story remains unfinished. Black holes offer another remarkable example. For centuries, no one even imagined such objects could exist. Then Einstein's equations hinted at their possibility. Later, astronomers gathered overwhelming evidence that black holes populate galaxies throughout the universe. Today, we have photographed the shadow of a supermassive black hole and detected gravitational waves from black hole mergers. These achievements would have seemed almost miraculous only a generation ago. Yet black holes continue presenting some of the deepest unanswered questions in science. What happens inside the event horizon? Does information truly disappear? Can quantum mechanics and gravity somehow reconcile within these extraordinary environments? Each breakthrough has only expanded the mystery. Dark matter follows the same pattern. Astronomers carefully measured the motions of stars within galaxies and noticed something astonishing. Galaxies rotated too quickly. Visible matter alone could not produce enough gravity to hold them together. Something unseen appeared to dominate the universe. Today, scientists estimate that ordinary matter represents only a small fraction of everything that exists. Most of the cosmos appears to consist of invisible dark matter and equally mysterious dark energy. We have become extraordinarily skilled at measuring their effects, yet we still do not know exactly what they are. The universe quietly reminds us that understanding one layer often reveals another hidden beneath it. Even time itself refuses to surrender completely. We experience time as something flowing steadily from past toward future. Yet modern physics paints a far stranger picture. Time slows near massive objects. It stretches at high speeds. Some equations remain almost perfectly symmetrical, whether time moves forward or backward. At the quantum level, our ordinary intuition begins to lose its familiar certainty. What then is time? A fundamental ingredient of reality? An emergent property? A consequence of entropy? Or something even more profound that we have not yet imagined? The question remains beautifully open. Life presents perhaps the most personal mystery of all. Scientists have learned extraordinary details about biology. We understand DNA, evolution, cells, ecosystems, and countless molecular processes that earlier generations could scarcely imagine. Yet consciousness continues to puzzle even the brightest minds. How does subjective experience emerge from physical matter? Why should collections of neurons produce awareness? Why does the universe contain beings capable of wondering about the universe itself? We possess remarkable pieces of the puzzle. The complete picture still waits patiently beyond the horizon. Perhaps this endless unfolding should not discourage us. Perhaps it should inspire us. Imagine reading an extraordinary novel. Would you truly want every mystery explained within the first few pages? Much of the beauty lies in discovering the story gradually. Unexpected twists, new characters, questions that quietly deepen with every chapter. The universe appears to have written itself in much the same spirit. Each answer enriches the narrative rather than ending it. Curiosity survives because mystery survives. Even the observable universe reminds us of our limits. Light travels at a finite speed. Only a certain portion of the cosmos has had enough time to become visible since the Big Bang. Beyond that cosmic horizon may lie regions forever beyond our observation. Not because they do not exist, simply because their light may never reach us. There may always remain aspects of reality that no telescope, no matter how advanced, can ever directly observe. That possibility feels strangely humbling. It also feels profoundly beautiful. Human history reflects the same pattern. Every generation inherits questions from those who came before, then adds new questions for those who follow. Ancient astronomers wondered what stars were. Modern astronomers ask how galaxies first assembled. Future scientists may investigate mysteries we cannot yet even imagine. Knowledge does not conclude, it evolves. Perhaps this is exactly how the universe intended its story to unfold. There is something deeply peaceful about accepting that complete certainty may never arrive. Modern life often encourages us to seek final answers, definitive conclusions, perfect understanding. The cosmos gently offers another way. It suggests that wonder itself may be one of the greatest destinations, not because answers lack value, but because curiosity keeps life endlessly alive. A universe with no remaining mysteries might eventually become strangely quiet. Instead, ours continues surprising us with extraordinary generosity. Every solved equation opens another frontier. Every successful mission reveals new destinations. Every discovery quietly whispers that countless others still wait beyond today's horizon. Standing beneath the stars tonight, the sky feels wonderfully different. It no longer appears as a collection of distant objects waiting to be completely cataloged. Instead, it resembles an endless invitation. Every constellation becomes another question. Every galaxy, another unfinished chapter. Every faint point of light, another reminder that reality remains far larger than any single generation could ever fully comprehend. Perhaps that is why the night sky never loses its power to inspire. It does not simply offer answers, it offers possibilities. It reminds us that no matter how much humanity learns, the universe will almost certainly continue revealing deeper layers of beauty, complexity, and mystery to every generation willing to keep looking upward with patient curiosity. And perhaps that is the greatest gift of all. Not a universe that can be completely explained, but one that forever rewards those who continue asking gentle questions beneath its endless stars. If these gentle reflections help you drift peacefully through the mysteries of science and the universe, don't forget to subscribe so we can continue exploring together on future nights beneath the stars. 8. The places where time moves differently. Across the universe, time may not flow with the same quiet rhythm everywhere. In some places, reality itself experiences the passage of moments in astonishingly different ways. Imagine carrying two perfectly identical clocks. Both begin ticking at exactly the same instant. One remains safely on Earth, the other embarks upon an extraordinary journey, racing through space at incredible speed before returning home many years later. When the two clocks are finally placed side by side again, something impossible seems to have happened. They no longer agree. One has measured more time than the other. Neither clock is broken. Neither has made a mistake. Instead, the universe itself has quietly treated them differently. Across the universe, time may not flow with the same quiet rhythm everywhere. In some places, reality itself experiences the passage of moments in astonishingly different ways. For most of human history, time appeared wonderfully simple. Morning became afternoon. Afternoon faded into evening. The seasons followed one another with reassuring regularity. Generations were born, grew old, and passed away. Time seemed like an invisible river carrying everything forward at exactly the same pace. Whether someone stood atop a mountain or beside the sea, whether they traveled or remained still, time appeared perfectly fair. Every clock ticked together. Every heartbeat belonged to the same universal rhythm. It was one of the most comfortable assumptions humanity had ever made. Then, during the early 20th century, Albert Einstein quietly transformed that picture forever. His theory of relativity introduced an idea so astonishing that even today it feels almost unbelievable. Time is not absolute. It is flexible. It stretches. It slows. Under certain circumstances, it even flows at different rates for different observers. The universe does not distribute time equally. Instead, time becomes part of the living fabric of reality itself. To understand this strange idea, imagine once again that great cosmic river. Perhaps it is not flowing at identical speed everywhere. Perhaps, like a river crossing varied landscapes, it moves swiftly through some regions while slowing almost to stillness in others. Every traveler experiences the journey differently depending upon where they are. Reality appears to behave in much the same way. One way time changes involves motion itself. The faster an object travels, the more slowly time passes for it compared with someone remaining relatively still. This effect, called time dilation, remains almost imperceptible at everyday speeds. A commercial airplane flying across continents experiences only tiny differences measured in fractions of a microsecond. No passenger notices. No ordinary clock reveals anything unusual. Yet careful experiments have repeatedly confirmed that the effect is real. Atomic clocks flown aboard aircraft return ever so slightly out of sync with identical clocks left on Earth. Nature quietly keeps perfect records. As speed increases toward the speed of light, however, the effect becomes extraordinary. Imagine a spacecraft capable of traveling at 99% of light speed. For the astronauts aboard, life might seem almost perfectly ordinary. Their hearts continue beating. Meals are shared. Conversations unfold. The stars drift quietly outside their windows. They experience each passing day much as they always have. Yet, when they eventually return home, they may discover that decades or even centuries have passed on Earth. For them, only a few years have elapsed. The universe has allowed different observers to experience different amounts of time. Not because anyone cheated, not because clocks malfunctioned, simply because reality itself behaves this way. Science fiction has often borrowed this remarkable consequence of relativity. Yet unlike many fictional ideas, this one rests firmly upon experimental evidence. The universe truly permits such astonishing possibilities. Motion alone can reshape the passage of time. Gravity offers another equally remarkable influence. Einstein realized that gravity does not merely pull objects together, it also changes time itself. Near massive bodies, time flows more slowly. The stronger the gravitational field, the greater the effect. Here on Earth's surface, gravity already slows time ever so slightly, compared with satellites orbiting high above the planet. The difference is tiny, yet it becomes enormously important. Without correcting for relativistic time dilation, the satellites guiding global positioning systems would gradually drift farther and farther from accurate timing. Within only a single day, navigation errors would grow by kilometers. Every time you use satellite navigation, relativity quietly works behind the scenes. The universe's strange treatment of time has become part of ordinary life. Now imagine approaching something far more extreme: a neutron star. These extraordinary objects compress more mass than our sun into a sphere only about 20 kilometers across. Their gravity becomes almost unimaginable. Time near their surfaces slows dramatically compared with regions farther away. A clock resting there would tick more slowly than one orbiting at a safer distance. Reality itself bends beneath overwhelming gravity. Black holes take this idea to breathtaking extremes. Near a black hole's event horizon, gravity becomes so intense that time slows enormously. To a distant observer, watching someone approach the event horizon, the traveler appears to move more and more slowly. Their motions gradually fade. Their clock seems to tick ever more gently. Light leaving them becomes increasingly stretched toward red wavelengths. Eventually, they appear almost frozen near the edge. Yet for the traveler themselves, something entirely different unfolds. they continue experiencing time normally. Their heartbeat remains steady, their thoughts continue flowing, their watch never seems unusual. Again, the universe quietly reminds us that perspective matters. Different observers may describe time differently, while both remain completely correct. This realization challenges something deeply rooted within human intuition. We often imagine that there must exist one universal now, one single present moment shared equally throughout the cosmos. Relativity gently suggests otherwise. Events that appear simultaneous for one observer may not appear simultaneous for another moving differently. The concept of now becomes far more subtle than everyday experience suggests. The universe possesses no giant master clock ticking identically for every star, planet, and galaxy. Instead, every observer carries their own journey through space-time. Even light participates in this extraordinary story. Because nothing carrying information can travel faster than light, every observer receives the universe's messages with slight delays. When you look toward the sun, you see it as it existed about 8 minutes ago. The nearest stars appear years in the past. Distant galaxies reveal themselves as they were billions of years earlier. The night sky already contains many different moments woven together into one magnificent view. Looking upward is never simply looking across space. It is looking through many different layers of time simultaneously. The universe becomes an immense tapestry where countless moments quietly coexist. Perhaps one of the most beautiful consequences of all this is philosophical rather than mathematical. Time feels deeply personal. Every human life unfolds according to its own rhythm. Childhood often seems endless. Years appear slower. Then adulthood arrives, and decades seem to pass with astonishing speed. Although psychology differs from relativity, both remind us that time has never been as simple as clocks alone suggest. Its experience depends upon circumstance. Its meaning depends upon perspective. Its passage is richer than our ordinary intuition first assumes. Standing beneath the stars tonight, the heavens begin to feel wonderfully different. Some distant neutron star quietly measures time more slowly than Earth. Near a supermassive black hole at the center of another galaxy, moments stretch into astonishing lengths. Fast-moving particles born inside exploding stars experience journeys unlike anything familiar to us. Across the observable universe, billions of different clocks quietly follow their own elegant rhythms. Yet somehow, despite these extraordinary differences, the cosmos remains beautifully harmonious. Galaxies still evolve, stars continue shining, planets quietly orbit. Life awakens. Curious minds emerge to ask questions about time itself. Perhaps that is the greatest wonder. The universe does not require every place to share the same clock. Instead, it allows countless different rhythms to coexist within one magnificent cosmic symphony, where every moment unfolds exactly as the laws of nature intend, reminding us that time is not a rigid ruler imposed upon reality, but one of the universe's most graceful and mysterious creations, endlessly flowing according to the quiet geometry of space-time itself. 9. The universe that constantly reinvents beauty. Nature never repeats itself perfectly. Using the same timeless laws, the universe quietly creates endless forms of beauty that have never existed before. Close your eyes for a moment and picture a snowflake falling silently through the winter air. Its 6 delicate branches appear almost impossibly symmetrical. Every crystal seems perfectly designed. And yet, despite centuries of careful observation, no one has ever found 2 large snowflakes that are completely identical in every detail. The same water, the same physical laws, the same chemistry. Yet every tiny journey through the clouds creates a pattern that has never existed before and will never exist again. Perhaps the universe has always worked this way. Nature never repeats itself perfectly. Using the same timeless laws, the the universe quietly creates endless forms of beauty that have never existed before. There is something deeply remarkable about this idea. The laws governing reality appear astonishingly stable. Gravity behaves today much as it did billions of years ago. Light travels according to the same elegant principles across the observable universe. Atoms follow familiar patterns wherever astronomers look. The universe does not constantly invent new rules. Instead, it creates infinite variety using the same beautifully consistent foundation. It resembles a composer writing countless symphonies using only 12 musical notes. The notes remain unchanged. The melodies never truly end. This quiet creativity can be seen almost everywhere we look. Consider galaxies. Astronomers estimate that the observable universe contains hundreds of billions of them. Many are graceful spirals like our own Milky Way. Others appear as smooth elliptical islands of ancient stars. Still others look irregular, distorted by collisions or shaped by turbulent histories. Some possess elegant central bars stretching across their glowing disks. Others display enormous rings. Some are quietly forming stars. Others have nearly exhausted their supply of gas. No two galaxies share precisely the same story. Each one becomes a unique expression written with the same cosmic alphabet. Gravity never changes. Its creations never stop surprising us. Stars tell a similar story. Every star begins with collapsing clouds of hydrogen. Every one shines because nuclear fusion transforms lighter elements into heavier ones. The underlying physics remains beautifully familiar, yet stars themselves display astonishing diversity. Tiny red dwarfs burn so slowly, they may outlive our sun by trillions of years. Massive blue giants blaze brilliantly before ending their lives in spectacular explosions. Some exist alone. Others orbit companions in intricate dances lasting millions of years. Some gather into magnificent clusters. Others wander quietly through lonely regions of space. Each star follows the same universal principles. Each life unfolds differently. Planetary systems perhaps reveal this creativity even more dramatically. For centuries, humanity knew only the planets surrounding our own sun. Today, thousands of worlds have been discovered orbiting distant stars. Some are larger than Jupiter, yet circle astonishingly close to their suns. Others resemble enormous oceans wrapped around rocky cores. Some appear locked so that one side permanently faces their parent star, while the opposite side remains in eternal darkness. There are planets where molten rock rains from the sky. Others where winds may blow faster than the speed of sound. Some possess multiple suns rising above their horizons. Others drift alone through interstellar space without any star at all. The universe never seems content to create only one version of beauty. It explores possibility with extraordinary imagination. Even within our own solar system, this endless creativity becomes impossible to ignore. Mercury is a scorched world marked by ancient impacts. Venus hides beneath thick clouds while its surface glows with intense heat. Earth overflows with liquid water and astonishing biodiversity. Mars preserves valleys carved by long-vanished rivers. Jupiter commands a family of dozens of moons, while storms larger than our planet rage across its atmosphere. Saturn surrounds itself with breathtaking rings composed of countless icy fragments. Beyond lie Uranus and Neptune, mysterious giants wrapped in deep blue atmospheres. The same laws produced them all. No two became alike. Nature seems to delight in variation. This remarkable principle continues on even smaller scales. Leaves growing upon the same tree share common patterns. Yet no two display identical arrangements of veins. Clouds drift according to familiar atmospheric physics. Still, each formation appears unique. Coastlines follow the patient work of waves, tides, and erosion. Yet every shoreline possesses its own unmistakable character. Mountains rise through similar geological processes across countless worlds. Still, each range tells a different story carved by time. The universe appears endlessly inventive without ever abandoning consistency. Mathematics quietly supports this astonishing richness. Simple equations often produce remarkably complex outcomes. Tiny differences in starting conditions may gradually evolve into dramatically different structures. A slight variation in the density of ancient hydrogen clouds eventually influences where galaxies form. Small differences accumulate, patterns emerge, complexity blossoms. The universe does not need infinite rules. It simply allows infinite possibilities to grow from elegant beginnings. Perhaps nowhere is this more beautifully illustrated than in life itself. Every living organism on Earth relies upon the same genetic language. DNA uses only 4 chemical letters. From those 4 simple components emerge towering redwood forests, graceful whales, colorful butterflies, microscopic bacteria, coral reefs, orchids, elephants, hummingbirds, and human beings capable of contemplating the stars. An alphabet of astonishing simplicity gives rise to endless creativity. Nature rarely repeats the exact same sentence twice. Evolution itself depends upon this balance between stability and novelty. DNA faithfully preserves successful information from one generation to the next. Yet, tiny variations occasionally appear. Most change very little. Some disappear entirely. Others quietly open new possibilities. Over immense spans of time, these subtle differences produce extraordinary diversity. Without variation, evolution would stop. Without stable rules, life could never continue. Beauty emerges because both consistency and creativity exist together. There is something deeply comforting hidden within this pattern. Sometimes we worry that repetition makes life ordinary. The sunrise arrives each morning. The seasons return. The stars follow familiar paths. Routine seems inevitable. Yet nature gently reminds us that repetition and originality are not opposites. The sunrise never illuminates exactly the same clouds. Autumn never paints identical forests. Ocean waves never arrange themselves in precisely the same way. Even familiar rhythms quietly create new moments every day. Perhaps this explains why the universe never feels exhausted despite its immense age. Nearly 14 billion years have passed since the beginning of cosmic history. One might imagine that every beautiful arrangement has already been created. Instead, new stars continue forming, new planetary systems continue emerging, galaxies continue colliding, life continues evolving. The story never simply repeats itself. It keeps discovering new ways of expressing the same timeless principles. Even humanity participates in this endless creativity. Every child inherits ancient atoms forged inside long-vanished stars. Every mind develops through familiar biological processes. Yet every individual carries unique experiences, memories, ideas, and dreams. The universe does not merely create people. It creates perspectives that have never existed before. Each life becomes another original chapter written with materials billions of years old. Standing beneath the night sky tonight, the stars seem wonderfully different. They no longer appear as countless copies scattered randomly across darkness. Instead, each becomes an unrepeatable masterpiece shaped by its own extraordinary history. Every nebula, every moon, every comet, every distant galaxy represents another expression of nature's endless imagination. The same quiet laws continue guiding them all. Yet, those laws never imprison creativity. They make creativity possible. Perhaps that is one of the deepest lessons the cosmos offers. True beauty does not require abandoning order. Instead, beauty flourishes because enduring principles provide the freedom for infinite variation. The universe has never needed new rules to create new wonders. With extraordinary patience, remarkable consistency, and limitless possibility, it continues reinventing beauty, moment after moment, generation after generation, ensuring that somewhere in the endless reaches of space and time, another breathtaking form has just come into existence, one that has never been seen before, and one that will never exist in quite the same way again. 10. Every beginning carries an ancient past. Nothing truly begins from nothing. Every new star, every planet, every living creature inherits a history written long before its own story starts. Imagine watching the birth of a brilliant new star. Deep inside a cold cloud of gas and dust, gravity slowly gathers scattered particles together. The cloud becomes denser, its temperature rises. After millions of patient years, an extraordinary moment finally arrives. Nuclear fusion ignites. A new sun begins shining where darkness once quietly rested. To any distant observer, it appears to be a beginning, a fresh chapter, a brand new light entering the universe. Yet, if that newborn star could somehow tell its story, it might whisper something surprising. I am not new at all. Every atom within it has traveled an astonishing journey. Its hydrogen remembers the earliest moments after the Big Bang. Its carbon once burned inside another ancient star. Its iron was forged during an explosion that happened long before this cloud even existed. Nothing truly begins from nothing. Every new star, every planet, every living creature inherits a history written long before its own story starts. Perhaps this is one of the universe's quietest truths. Every beginning is also an inheritance. When we speak about birth, we often imagine something appearing for the very first time. A child enters the world, a flower blooms, a mountain rises, a galaxy forms. Each event seems wonderfully fresh. Yet beneath every apparent beginning lies an invisible chain stretching backward through unimaginable time. Nature rarely creates from emptiness. Instead, it patiently transforms what already exists. The universe behaves less like an artist painting upon a blank canvas and more like a storyteller whose every chapter grows naturally from those that came before. Consider our own sun. About 4.6 billion years ago, it emerged from a giant molecular cloud drifting through one quiet region of the Milky Way. At first glance, that cloud may have seemed ordinary, a vast collection of gas and microscopic dust floating through darkness. But hidden within that cloud were the remains of countless earlier stars. Some had lived billions of years before. Others had ended only relatively recently. Each contributed something precious. Hydrogen from the earliest universe, carbon from red giant stars, oxygen forged deep within stellar furnaces, silicon, magnesium, calcium, iron, and dozens of other elements scattered into space through magnificent supernova explosions. The cloud was not empty. It was a library filled with ancient memories. Gravity merely gathered the pages together into a new story. Earth inherited that remarkable legacy as well. Every rock beneath your feet contains atoms older than our planet. The oxygen filling our atmosphere began its existence inside stars that disappeared billions of years ago. The calcium strengthening your bones once traveled through stellar interiors, hot enough to melt imagination itself. Even the gold in a wedding ring may have originated during the collision of two neutron stars, an event so energetic that it briefly outshone entire galaxies. Long before human civilization existed, before Earth possessed oceans, before the sun itself had ignited, the ingredients of your world were already traveling through the cosmos. Our planet did not create them. It welcomed them. Nature repeats this beautiful pattern everywhere. A forest seems filled with endless new life each spring. Tiny seedlings emerge from the soil. Fresh leaves unfold toward sunlight. Birds build new nests among growing branches. Yet nothing in the forest begins without history. The soil itself contains generations of fallen leaves. Ancient trees slowly return their nutrients to the earth. countless microorganisms quietly transform yesterday's life into tomorrow's nourishment. Every new plant grows because earlier life prepared the ground. The forest remembers, even when no creature consciously recalls its past. Life on Earth follows the same quiet rhythm. Every living cell carries instructions copied across billions of years of evolution. The DNA inside every organism contains echoes of unimaginably ancient ancestors. Your heartbeat depends upon biological systems refined long before mammals appeared. Your eyes inherited solutions developed by countless earlier forms of life learning how to gather light. Even the simplest bacteria alive today preserve molecular strategies that stretch back toward the earliest chapters of Earth's history. Evolution does not erase the past. It builds upon it, generation after generation. Success becomes inheritance. Inheritance becomes possibility. Human civilization reveals this pattern beautifully as well. Every discovery rests upon discoveries made earlier. Writing preserved knowledge. Libraries protected it. Printing multiplied it. Science expanded it. Education passed it onward. The technology surrounding us today exists because countless people, separated by centuries and continents, each quietly added another small piece to humanity's growing understanding. No inventor begins completely alone. Every new idea carries invisible companions from the past. Even language itself illustrates this extraordinary continuity. Every sentence spoken today descends from languages shaped over thousands of years. Words evolve, meanings shift, sounds change. Yet, the conversation never truly begins from nothing. Every voice inherits countless earlier voices. Perhaps the universe speaks in exactly this way, not through isolated events, through continuous stories. Astronomers often describe stellar evolution using the phrase stellar generations. The term is wonderfully appropriate. One generation of stars lives and dies. Its ashes enrich surrounding space. Another generation forms from that material. Those newer stars eventually produce future generations of their own. The cosmos quietly resembles an enormous family tree stretching across billions of years. Our sun belongs to one branch. Future stars will descend from ours. The conversation continues. Galaxies themselves possess family histories. The Milky Way did not appear fully formed. Over immense spans of time, it merged with smaller galaxies. It absorbed wandering star clusters. It welcomed new clouds of gas drifting through intergalactic space. Some stars now shining above Earth were born elsewhere before joining our galaxy through ancient cosmic encounters. Even the Milky Way carries memories written across countless earlier structures. Nothing stands entirely apart from history. Perhaps one of the most touching examples lies much closer to home. Take a slow breath. The oxygen entering your lungs has almost certainly passed through countless living creatures before reaching you. It may once have been breathed by dinosaurs. It may have circulated through ancient forests. It may have drifted above forgotten civilizations. Tomorrow, it will continue traveling. The atoms participating in your life will someday join rivers, oceans, plants, animals, clouds, and perhaps future human beings. Matter remains astonishingly faithful to its endless journey. Only its arrangements continue changing. There is something deeply comforting hidden within this realization. Modern life often celebrates novelty, the newest technology, the newest discovery, the newest generation. Yet the universe quietly reminds us that genuine novelty never rejects the past. Instead, it embraces inheritance. Every remarkable beginning grows stronger because ancient foundations patiently support it. Perhaps this also changes how we think about ourselves. It is easy to feel isolated when viewing life as a single brief chapter. Yet the universe gently offers another perspective. Each of us represents an extraordinary continuation rather than an isolated beginning. Your body contains atoms forged inside stars. Your mind inherits millions of years of evolution. Your ideas build upon generations of human thought. Your future actions will quietly influence lives not yet born. You are not separate from cosmic history. You are one of its newest expressions. Standing beneath the stars tonight, every point of light begins to feel richer than before. Each shining sun carries memories of earlier suns. Each planet preserves ancient ingredients older than itself. Each living world becomes another chapter in a story already billions of years long. The night sky transforms into something more than a collection of distant objects. It becomes an immense archive where every new beginning quietly honors countless ancient beginnings that made it possible. Perhaps that is the universe's greatest lesson about time. Nothing truly starts alone. Every birth carries invisible ancestors. Every sunrise follows countless earlier dawns. Every curious question grows from centuries of wondering. And every future discovery will inherit the quiet gifts of everything that came before, ensuring that the universe's endless story continues not as disconnected moments, but as one magnificent narrative where every new beginning gently carries the wisdom, matter, energy, and memories of an unimaginably ancient past into chapters that have not yet been written. 11. The quiet confidence of natural laws. The universe never hesitates. Across billions of years, its invisible laws continue guiding every atom with extraordinary consistency, allowing complexity to emerge from remarkable simplicity. Imagine tossing a single pebble into a perfectly still pond. The instant it touches the surface, gentle ripples begin spreading outward. Every wave follows another. Circles expand with quiet precision. No ripple suddenly changes its mind halfway across the water. No wave forgets how to move. Every tiny motion unfolds according to the same dependable principles that have governed water for as long as oceans have existed. The pond never hesitates. It never wonders what should happen next. Its invisible rules quietly shape every movement with effortless consistency. Perhaps the entire universe behaves much the same way. The universe never hesitates. Across billions of years, its invisible laws continue guiding every atom with extraordinary consistency, allowing complexity to emerge from remarkable simplicity. This quiet reliability may be one of reality's greatest miracles. Because natural laws never lose confidence, everything else becomes possible. Imagine how different the cosmos would be if gravity occasionally forgot its strength. Suppose light traveled at one speed today, but another tomorrow. Imagine electrons deciding at random whether they wished to orbit atomic nuclei. Stars would never remain stable. Chemistry would collapse. Planets could not hold their paths. Life itself would have almost no opportunity to appear. Complexity depends upon reliability. The extraordinary richness of existence rests upon astonishing consistency. For most of history, humanity gradually discovered this truth without fully recognizing its significance. Ancient civilizations watched the sun rise every morning. The moon followed familiar phases. The seasons returned with remarkable regularity. Farmers planted crops because nature proved trustworthy. Navigators crossed oceans because stars occupied predictable positions. Long before anyone understood gravity or orbital mechanics, people quietly relied upon laws they could not yet describe. The universe earned trust simply by behaving consistently. Science later transformed that trust into understanding. Isaac Newton observed an apple falling from a tree and asked one of history's simplest yet most profound questions. Could the same force pulling fruit toward Earth also guide the moon around our planet? The answer changed everything. One elegant principle appeared capable of describing events separated by enormous distances. The falling apple and the orbiting moon belonged to the same invisible order. Nature was not improvising. It was following dependable laws everywhere. Later generations expanded that remarkable realization. James Clerk Maxwell revealed that electricity and magnetism formed different expressions of one unified phenomenon. Albert Einstein showed that gravity itself emerges from the geometry of space-time. Quantum mechanics uncovered astonishing rules governing atoms and subatomic particles. Again and again, scientists discovered not chaos hidden beneath appearances, but deeper levels of extraordinary consistency. Reality seemed beautifully committed to coherence. Perhaps the greatest evidence of this confidence appears in light itself. Every photon traveling through empty space obeys the same fundamental principles, regardless of where it was born. Light leaving a nearby candle follows the same physical laws as light departing a galaxy billions of light years away. Some photons reaching Earth's telescopes tonight began their journeys before our solar system even existed. Across unimaginable distances and immense stretches of time, they never abandoned the rules governing their motion. The universe quietly preserved remarkable order over billions of years. Gravity demonstrates similar faithfulness. Every object possessing mass participates in its invisible influence: a grain of sand, a mountain, a planet, a galaxy. Gravity never chooses favorites. It never becomes distracted. Patiently, endlessly, it shapes orbits, gathers stars, forms galaxies, and sculpts the large-scale architecture of the cosmos. Its quiet confidence has remained unchanged since the earliest moments after the Big Bang. Stars owe their existence to this extraordinary reliability. Inside every star, gravity continually pulls matter inward. Nuclear fusion pushes outward. These opposing influences maintain a delicate balance lasting millions or even billions of years. If either process behaved unpredictably, stars could never remain stable long enough to illuminate planets or manufacture the elements required for life. Instead, natural laws quietly cooperate. The sun has risen above Earth's horizon for over 4 billion years because the universe faithfully continues honoring the same invisible agreements. Chemistry offers another astonishing example. Hydrogen atoms combine with oxygen to form water, carbon bonds with remarkable flexibility, creating molecules capable of extraordinary complexity. DNA stores information using dependable chemical interactions repeated countless trillions of times inside living organisms. Every heartbeat depends upon predictable molecular behavior. Every breath relies upon atoms faithfully following familiar patterns. Life itself becomes possible because chemistry never suddenly invents new rules. Its quiet consistency provides biology with a dependable foundation upon which evolution patiently builds. Perhaps this is why simplicity often proves so surprisingly powerful. The equations describing gravity appear remarkably concise. Maxwell's equations elegantly summarize electromagnetism. The mathematical relationships underlying quantum mechanics fit upon surprisingly few pages. Simple principles, endless consequences. It resembles planting a single seed capable of growing into an immense forest. The original instruction remains compact. Its unfolding possibilities become almost limitless. Nature seems remarkably fond of this strategy. Rather than creating infinite rules, it allows a small collection of dependable principles to generate infinite variety. Snowflakes beautifully illustrate this idea. Every snowflake forms according to identical physical laws governing water molecules. Temperature, humidity, and microscopic environmental differences influence each crystal's growth. The rules remain constant. The outcomes become wonderfully diverse. Billions upon billions of unique snowflakes quietly demonstrate how consistency and creativity coexist without contradiction. Galaxies tell the same story on a vastly larger scale. Gravity shapes them all, yet no two possess precisely identical histories. The laws remain unchanged. The universe endlessly discovers new expressions of their possibilities. There is something deeply comforting hidden within this observation. human lives often feel uncertain. Plans change, circumstances evolve, unexpected events arrive without warning. The future remains wonderfully unpredictable. Yet beneath those uncertainties, the deeper structure of reality remains astonishingly dependable. The atoms composing your body continue obeying the same principles that governed ancient stars. Earth faithfully circles the sun. The moon continues raising tides. Light continues crossing the darkness between galaxies. Nature's confidence quietly supports every moment of existence. Modern technology depends entirely upon this trustworthiness. Computers function because electrons consistently behave according to quantum mechanics. Spacecraft navigate using precisely predictable gravitational interactions. Medical imaging relies upon dependable electromagnetic behavior. Satellite communication depends upon the unwavering speed of light. None of these achievements would exist if natural laws hesitated even slightly. Civilization itself quietly rests upon the universe's extraordinary reliability. Perhaps this explains why scientists often describe discovering physical laws rather than inventing them. The equations exist long before anyone writes them down. Human understanding gradually uncovers patterns already patiently governing reality. The universe never required our approval. Its laws were quietly shaping stars billions of years before intelligent observers appeared to notice. There is profound humility in recognizing this. We are not watching reality decide how to behave. We are slowly learning the language it has spoken from the beginning. Standing beneath the stars tonight, the sky begins to feel different once again. Every constellation, every planet, every distant galaxy shines because invisible principles continue working with absolute faithfulness. No cosmic supervisor issues daily instructions. No hidden engineer constantly adjusts every orbit. Instead, elegant natural laws quietly guide every atom with extraordinary confidence. Moment after moment, century after century, galaxy after galaxy. Their patience has never weakened. Their consistency has never faltered. And because of that unwavering reliability, hydrogen became stars. Stars forged the elements. Planets formed. Life emerged. Consciousness awakened. And somewhere on one quiet world, curious minds began asking why the universe seems so beautifully certain of itself. Perhaps that quiet confidence is the deepest foundation of all existence. Not loud, not dramatic, simply steadfast, beyond imagination. The universe never hesitates because it never needs to. Its invisible laws have already been writing the same elegant story for nearly 14 billion years, allowing infinite beauty, endless complexity, and every future wonder to emerge naturally from principles so simple that they continue guiding the entire cosmos with the calm certainty of a symphony that has never once forgotten how its music is meant to unfold. 12. The future already hidden. Inside the present. Perhaps tomorrow's greatest discoveries are already quietly taking shape around us today, invisible only because we have not yet learned where or how to look. If these peaceful stories bring a little wonder before sleep, subscribe and continue exploring the hidden future of the cosmos with us on our next quiet journey through the stars. Imagine standing in a quiet forest a century ago. Around you are towering trees whose branches seem timeless. Birds sing overhead. The wind moves gently through the leaves. Nothing appears unusual. Yet hidden beneath the soil, invisible to every passing traveler, tiny acorns have already begun sending delicate roots into the earth. Those fragile seedlings are almost impossible to notice. Most people walk past without ever seeing them. But within those quiet beginnings already lies the outline of tomorrow's forest. The future has not suddenly appeared. It has been patiently growing all along. Perhaps the universe has always worked this way? Perhaps tomorrow's greatest discoveries are already quietly taking shape around us today, invisible only because we have not yet learned where or how to look. History offers countless reminders that the future rarely announces itself with dramatic fanfare. Instead, it often arrives disguised as something small, ordinary, or easily overlooked. When Galileo first turned his telescope toward Jupiter in 1610, he saw 4 tiny points of light changing position from night to night. At first glance, they hardly seemed extraordinary. Yet those faint moons quietly shattered humanity's ancient picture of the cosmos. If objects could orbit Jupiter instead of Earth, perhaps Earth was not the center of everything after all. One careful observation transformed our understanding of the universe. The future of astronomy had already been waiting in the night sky. Someone simply needed to notice it. The same pattern appears throughout science. When Michael Faraday experimented with coils of wire and moving magnets, he could not foresee electric power grids stretching across continents. When James Clerk Maxwell wrote elegant equations describing electromagnetic waves, radio, television, satellites, and wireless communication still belonged to unimaginable futures. When early physicists explored the strange behavior of atoms, they were not trying to invent computers, lasers, or medical imaging. They were simply following curiosity. The future quietly hid inside their questions long before anyone recognized its shape. Perhaps this is one of nature's favorite habits. Great revolutions often begin as whispers. Even the stars tell this story. Somewhere within enormous molecular clouds drifting silently through our galaxy, gravity is already gathering tiny regions of gas together. Nothing spectacular is visible. No brilliant sunlight shines. No planets circle newborn stars. From a distance, these clouds appear calm and uneventful. Yet inside them, tomorrow's solar systems are already beginning. Future suns, future planets, perhaps future oceans, perhaps future life, perhaps future civilizations wondering about their own place in the cosmos. Everything remains invisible because the story is still in its earliest chapter. Astronomers today can observe these stellar nurseries with powerful telescopes. They see faint hints of structures slowly emerging, disks of dust, condensing clouds, subtle movements. The future has already begun. It simply moves too slowly for impatient eyes. Earth itself continues preparing futures we cannot yet fully imagine. Deep beneath volcanic regions, continents slowly drift across the planet's surface. Mountain ranges quietly rise, ocean basins gradually widen. The landscapes familiar today will someday become entirely different. Millions of years from now, coastlines will occupy new positions. Entire ecosystems will evolve around environments not yet formed. The Earth has never stopped becoming. Its future quietly unfolds beneath every present moment. Life follows exactly the same rhythm. Evolution never waits until tomorrow to begin changing. Every generation carries tiny genetic variations. Most seem insignificant. Some disappear entirely. Others quietly become the foundation for remarkable future adaptations. The next great evolutionary innovation may already exist inside an organism alive today. Not fully expressed, not yet recognized, simply waiting for the right conditions. Nature often prepares tomorrow long before anyone realizes preparation has begun. Human knowledge evolves in remarkably similar ways. Right now, somewhere in a laboratory, a student may be making an observation that seems almost unimportant. A small discrepancy, a curious measurement, an unexpected result. Years later, that overlooked detail could become the foundation of an entirely new understanding. History is filled with such moments. Alexander Fleming noticed mold growing inside one forgotten laboratory dish. The observation appeared almost accidental. Yet, from that quiet beginning, came penicillin, transforming medicine forever. The future often hides inside ordinary moments because nobody yet understands what they truly contain. Astronomy today may be experiencing many such moments. Dark matter remains mysterious. Dark energy appears even stranger. Fast radio bursts flash briefly across distant galaxies. The interiors of black holes continue resisting complete explanation. Quantum gravity remains elusive. Every one of these puzzles may contain discoveries capable of reshaping humanity's picture of reality. The answers may already exist, perhaps hidden within observations already collected, perhaps waiting inside equations not yet interpreted correctly, perhaps resting quietly inside data nobody has fully understood. The universe rarely withholds its secrets forever. More often, it patiently waits until curious minds become ready to recognize them. There is something deeply hopeful about this. We sometimes imagine discovery as something lying far away in distant futures, yet many future breakthroughs may already surround us. They exist not because nature has suddenly changed, but because our understanding continues evolving. The stars above our ancestors were exactly the same stars we observe today. The galaxies existed before telescopes. Gravitational waves crossed the universe long before detectors finally measured them. Reality patiently remained itself, while humanity slowly learned how to listen. Perhaps the greatest discoveries of the next century are already quietly passing through our instruments. Perhaps entirely new forms of life exist beneath the icy oceans of distant moons, awaiting exploration. Perhaps planets already cataloged today secretly possess atmospheres unlike anything previously imagined. Perhaps somewhere within existing astronomical images rests evidence that will one day transform cosmology. The future often begins long before recognition arrives. Even artificial intelligence reflects this familiar rhythm. Only a few decades ago, computers struggled with tasks now considered routine. Tiny improvements accumulated gradually. Faster processors, better algorithms, larger data sets. Each advance appeared modest by itself. Together, they quietly reshaped society. No single moment announced the future. The future patiently assembled itself, one small improvement at a time. Perhaps this gradual unfolding reflects something even deeper about reality. The universe does not seem interested in sudden perfection. Instead, it cultivates possibility. Every present moment contains seeds reaching toward countless different futures. Some never grow, others flourish beyond imagination. The richness of tomorrow depends upon the quiet potential already resting inside today. Standing beneath the stars tonight, it becomes comforting to realize that the cosmos has never finished preparing its next surprise. Some distant cloud is already becoming tomorrow's star. Some newborn planet is cooling beneath unfamiliar skies. Some faint signal crossing intergalactic space has not yet reached Earth. Some young scientist is asking a question that may eventually transform an entire field. Some child looking upward tonight may someday solve a mystery that has puzzled generations. The future is not empty. It is quietly under construction. Perhaps that realization changes how we see the present itself. Today is no longer merely a brief moment passing toward tomorrow. It becomes fertile ground where countless unseen possibilities are already taking root. Every observation matters. Every question matters. Every act of curiosity becomes another small light, illuminating paths that future generations may one day follow. The universe has always trusted time to reveal what is already patiently unfolding beneath the surface. And perhaps that is why hope feels so natural beneath the stars. Not because we know exactly what tomorrow will bring, but because history gently reminds us that reality has always contained more possibility than any single generation could fully imagine. The greatest wonders ahead may not need to be invented at all. They may already exist, quietly waiting within the present moment, ready to reveal themselves when humanity finally learns where and how to look. If these peaceful stories bring a little wonder before sleep, subscribe and continue exploring the hidden future of the cosmos with us on our next quiet journey through the stars. 13. the questions the universe asks through us. Perhaps humanity did not invent curiosity at all. Perhaps the universe itself has simply learned to ask questions through minds that are made from its own ancient stardust. Imagine a universe completely empty of questions. Stars are born, galaxies collide, planets circle their suns, black holes slowly grow. Gravity continues shaping space-time exactly as it always has. Everything unfolds according to the elegant laws of physics. Yet throughout billions of years, not a single voice ever asks why any of it exists. No one wonders where the stars came from. No one gazes upward in quiet amazement. No mind pauses beneath the night sky to imagine what might lie beyond the faintest galaxies. The universe simply continues existing, magnificent but entirely unobserved. For nearly 14 billion years, something very close to that may have been true. The cosmos evolved in extraordinary beauty long before there was anyone capable of appreciating it. Then, on one small planet, orbiting one ordinary star among hundreds of billions, something astonishing happened. Matter began asking questions about matter. Perhaps humanity did not invent curiosity at all. Perhaps the universe itself has simply learned to ask questions through minds that are made from its own ancient stardust. This possibility carries a quiet kind of wonder. When we think about curiosity, we often imagine it as something uniquely human. Children ask endless questions. Scientists spend entire careers searching for answers. Philosophers wonder about existence. Artists search for meaning. Explorers venture toward unknown horizons. Curiosity feels deeply personal. It seems to belong to us. Yet, perhaps we have been looking at it from the wrong direction. Perhaps curiosity did not begin with humanity. Perhaps it has been slowly emerging throughout cosmic history, patiently preparing itself across billions of years until the universe finally became capable of wondering about its own existence. Consider the extraordinary chain that made this possible. The hydrogen created shortly after the Big Bang eventually gathered into stars. Those stars forged heavier elements inside their blazing interiors. Supernova explosions scattered those elements across space. New stars formed. Planets emerged. On at least one of those planets, chemistry slowly became biology. Biology gradually became consciousness. Consciousness eventually became curiosity. Each step depended completely upon every previous one. If any chapter had been missing, the next could never have appeared. The questions we ask today are the distant descendants of events that began almost at the birth of time itself. In that sense, every thoughtful conversation beneath the stars has roots reaching all the way back to the earliest moments of the universe. The atoms inside your brain once belonged to ancient stars. That statement has become familiar, yet its implications remain astonishing. Carbon, oxygen, nitrogen, calcium, phosphorus, and iron all traveled extraordinary journeys before becoming part of living minds. The very material now supporting your thoughts spent billions of years drifting through galaxies, burning inside stars, crossing interstellar space, and helping assemble a small blue planet. Eventually, those same atoms became neurons capable of reflection. The universe did not merely produce conscious beings, it transformed ancient stardust into questions. There is something profoundly beautiful about that transformation. For billions of years, gravity quietly shaped galaxies without ever asking what gravity was. Light crossed the expanding universe without wondering where it had begun. Planets circled stars without imagining tomorrow. Then life appeared. And eventually life began wondering. Some philosophers and scientists have occasionally suggested that consciousness represents one of the universe's most remarkable transitions. Not because it changes the physical laws themselves. The stars continue burning whether anyone observes them or not. Galaxies continue evolving in silent elegance. Instead, consciousness introduces something entirely new: experience, awareness. the ability to recognize patterns, the capacity to imagine futures, the willingness to ask questions that possess no immediate survival value. Why does mathematics describe nature so well? What happened before the Big Bang? Are we alone? Why does anything exist at all? These questions offer no food. They provide no shelter, yet they continue drawing humanity forward. Perhaps curiosity itself became another evolutionary force. Children naturally explore long before they understand why. They pick up stones, watch insects, stack blocks, point toward the moon, ask endless questions that often seem wonderfully impossible. Why is the sky blue? Where does the wind come from? Why do stars shine? Every child quietly reenacts humanity's oldest tradition, looking at reality and refusing to accept that mystery should remain unexplored. Maybe that instinct reaches deeper than culture. Perhaps it reflects something woven into the very history of the cosmos. Science itself demonstrates this remarkable continuity. Every generation inherits questions from those before it. The ancient Greeks wondered what matter was made of. Centuries later, atoms were discovered. Then subatomic particles. Then quarks. Now physicists search for even deeper structures. Each answer gives birth to another question. Knowledge expands. Curiosity expands with it. The process resembles evolution. Ideas reproduce. They change. They branch. Some disappear. Others transform entire civilizations. The universe seems to encourage endless inquiry rather than final certainty. Astronomy perhaps illustrates this better than any other science. Every improvement in our telescopes reveals more objects than expected. The Milky Way became one galaxy among countless others. Galaxies assembled into enormous clusters. Clusters formed immense filaments, stretching across the observable universe. Dark matter emerged. Dark energy followed. The deeper we look, the richer reality becomes. It almost feels as though the universe rewards curiosity by offering mysteries more beautiful than those already solved. Perhaps that reward is not accidental. Perhaps mystery itself keeps curiosity alive. Imagine if humanity learned absolutely everything tomorrow. Every equation completed, every mystery solved, every question answered. Would exploration continue? Would wonder remain? Or would something quietly fade? The universe seems remarkably careful never to allow that moment to arrive. Each horizon simply reveals another beyond it. The questions survive because reality remains wonderfully deeper than any single explanation. Even on the smallest scales, curiosity transforms ordinary moments into extraordinary ones. A biologist looking through a microscope, an astronomer examining faint starlight, a geologist holding an ancient fossil, a physicist studying subtle quantum behavior. Each person encounters the same universe everyone else inhabits, yet curiosity allows hidden stories to emerge. The familiar becomes astonishing. The ordinary becomes magnificent. Reality itself has not changed. Only the questions have. Perhaps that is one of curiosity's greatest gifts. It reveals that the universe has always contained more beauty than casual observation first suggests. There is also a quieter possibility. Perhaps the universe is not simply being observed through us. Perhaps it is gradually becoming more aware of itself through countless curious minds spread across space and time. If intelligent life exists elsewhere among the stars, other civilizations may also be asking remarkably similar questions. Different languages, different histories, different biology. Yet perhaps beneath those differences lies the same ancient impulse, matter wondering about matter, consciousness exploring consciousness, the cosmos patiently examining itself from many different perspectives. If that is true, then every thoughtful question becomes part of something far larger than humanity alone. Standing beneath the stars tonight, it becomes difficult to feel entirely separate from the universe. The air you breathe once belonged to ancient forests. The calcium in your bones formed inside long-vanished stars. The light entering your eyes left distant galaxies millions of years ago. Even your ability to wonder arose through a chain of events stretching back almost 14 billion years. You are not merely living inside the universe. You are one of the ways the universe continues discovering itself. Perhaps that is why curiosity feels so natural. Not because humans accidentally became inquisitive, but because the long history of the cosmos quietly prepared minds capable of asking questions that stars alone never could. Every telescope lifted toward the heavens, every equation written upon a blackboard, every child pointing upward at the night sky, every quiet conversation about existence, all of them become part of one magnificent dialogue that began when the first atoms formed and continues today through minds fashioned from those same ancient elements. The universe may never speak with words, yet through every curious heart and every wondering mind, it continues asking the oldest and most beautiful question of all. What else is waiting to be understood? 14. Why infinity always feels one step away. No matter how far we extend our understanding, infinity always seems to retreat just beyond the next horizon, inviting us to keep exploring forever. Stand on the shore of a vast ocean just before sunrise. The horizon stretches in every direction, calm and perfectly clear. You begin walking toward it. After an hour, the horizon still lies ahead. After an entire day, it remains just as distant. No matter how far you travel, the edge never allows itself to be reached. It simply moves forward with you, always revealing another piece of the world while quietly hiding everything beyond. Knowledge often feels remarkably similar. Every great discovery broadens our view, yet somehow the boundary of mystery never disappears. Instead, it grows alongside our understanding. No matter how far we extend our understanding, infinity always seems to retreat just beyond the next horizon, inviting us to keep exploring forever. Perhaps this is not a flaw in human knowledge. Perhaps it is one of reality's most extraordinary gifts. The universe never seems interested in giving us a final destination. Instead, it offers endless invitations. Every answer becomes another doorway. Every horizon quietly prepares the next. For thousands of years, people believed the Earth itself marked the limits of existence. The familiar sky arched overhead. The sun crossed from east to west. Beyond the visible horizon lay uncertainty. Then, sailors crossed vast oceans. The world became larger. Soon afterward, astronomers discovered that Earth was only one planet among several circling the sun. The universe expanded again. Centuries later, telescopes revealed that our sun belonged to an enormous galaxy containing hundreds of billions of stars. Again, the horizon moved. Then astronomers realized that the Milky Way itself represented only one galaxy among hundreds of billions scattered across the observable universe. Each breakthrough seemed enormous. Each eventually became another beginning. The farther humanity traveled, the farther infinity quietly stepped away. Mathematics perhaps understands this better than any other language. Imagine counting. 1, 2, 3, 10, 100, a million, a billion. No matter how large the number becomes, another always waits beyond it. Infinity never arrives. It remains permanently ahead. Not because counting has failed, but because infinity is not simply an extremely large number. It represents something fundamentally different, a direction rather than a destination. The universe often behaves in much the same way. Astronomy constantly reveals this beautiful pattern. Modern telescopes peer farther into space than anyone once believed possible. They detect galaxies whose light has traveled for more than 13 billion years before finally reaching Earth. Each improvement allows us to observe deeper into cosmic history. Yet beyond every observable boundary lies another question. What exists outside the observable universe? Does space continue forever? Does it curve back upon itself? Could countless other regions exist forever beyond our ability to observe? The farther we look, the more profoundly mystery expands. Even the observable universe carries invisible boundaries. Light travels at a finite speed. Because the cosmos possesses a finite age, only a certain amount of information has had enough time to reach us. There may already exist galaxies whose light will never arrive because the expansion of space itself carries them away faster than their photons can close the distance. Those galaxies remain real, whether we observe them or not. Infinity quietly whispers from beyond our cosmic horizon. The smallest scales reveal the same astonishing pattern. Early scientists believed atoms represented the ultimate building blocks of matter. Then electrons, protons, and neutrons appeared. Later came quarks, then quantum fields. Now physicists wonder whether still deeper structures remain hidden beneath everything currently understood. Each time humanity believes it has reached the foundation, another layer quietly emerges beneath it. Reality seems endlessly generous with its depth. Black holes remind us that horizons exist not only in space, but also in understanding. Their event horizons mark boundaries beyond which information cannot easily return. Outside observers can calculate astonishing details about black holes: mass, rotation, charge, gravitational influence. Yet what truly occurs within remains one of the deepest mysteries in modern physics. The closer we approach complete understanding, the more another horizon quietly appears. Infinity seems remarkably patient. It never disappears. It simply changes form. Even time invites similar reflections. The universe has existed for nearly 14 billion years. That span alone overwhelms ordinary imagination. Yet, compared with certain cosmological possibilities, even billions of years may represent only the opening pages of a much longer story. If the universe continues expanding indefinitely, future stars may continue forming for trillions of years. Tiny red dwarf stars could shine for periods so immense that our current age of the universe would seem almost youthful by comparison. Beyond them lie possibilities almost impossible to visualize. White dwarfs slowly cooling. Black holes gradually evaporating through processes predicted by theoretical physics. A future extending across intervals so enormous that familiar numbers lose their meaning. Again, the horizon quietly moves beyond imagination. Human curiosity reflects this endless motion beautifully. Every child begins asking simple questions. Why is the sky blue? Where do stars come from? Why does rain fall? Later, those questions become more subtle. How did life begin? What is consciousness? Why does mathematics describe reality so elegantly? What happened before the Big Bang? Each answer deepens rather than concludes the conversation. Curiosity behaves like light traveling endlessly toward another horizon. Perhaps this is why science never truly ends. It evolves. Each generation inherits unanswered questions from those before, then contributes new ones for those yet to come. Newton passed mysteries to Einstein. Einstein passed mysteries to modern cosmology. Today's researchers will quietly pass even richer mysteries to future scientists whose names remain unknown. The conversation continues because infinity continues inviting it. There is something deeply reassuring about this. Modern life often encourages completion. Finish the project, reach the destination, solve the problem, achieve certainty. The universe gently suggests another rhythm. Perhaps the most meaningful journeys never truly conclude. Perhaps their value lies precisely in their endless unfolding. Mountain climbers rarely love mountains because summits eliminate all future climbing. Readers rarely cherish books because stories immediately stop after the first chapter. Music remains beautiful because every note leads naturally toward another. Infinity transforms knowledge into an ongoing adventure rather than a finished task. Standing beneath the night sky, this realization becomes wonderfully tangible. Every star visible tonight belongs to a galaxy whose full history remains only partially understood. Every faint point of light carries unanswered questions. Beyond what our eyes can see lie billions more stars. Beyond those stars lie countless unseen galaxies. Beyond those galaxies may stretch regions forever inaccessible to observation. Reality seems content, allowing every discovery to become another beginning. Perhaps this is one reason wonder never grows old. The sky our ancestors admired remains the same sky inspiring astronomers today. Yet each generation discovers new depths hidden within familiar constellations. The heavens do not become smaller as knowledge increases, they become richer. Every explanation adds another layer of appreciation. Every solved mystery reveals subtler beauty waiting beneath. Perhaps infinity itself is less about endless distance than endless possibility. The universe never asks us to reach the final horizon. It simply invites us to keep walking. One careful observation, one thoughtful question, one quiet discovery after another. Each step expands both what we know and what we realize remains unknown. And perhaps that delicate balance is exactly what keeps curiosity alive across generations. The greatest explorers never journey because they expect the horizon to disappear. They journey because each new horizon reveals landscapes no one has ever seen before. The universe seems to offer the same invitation every night, not the promise of final answers, not the certainty of ultimate completion. Instead, it offers an endless procession of beautiful beginnings, each leading naturally toward another mystery waiting just beyond sight, ensuring that infinity forever remains one gentle step ahead, not to frustrate our search, but to preserve the endless wonder that has carried curious minds beneath the stars since the very first human being looked upward and realized that every horizon, no matter how distant, quietly whispered of another waiting beyond it. 15. The tomorrow. No telescope can yet see. Some of the universe's greatest wonders may already exist, not hidden by distance, but by ideas humanity has not yet imagined. Imagine showing a modern smartphone to someone living 1,000 years ago. The screen lights up. Voices travel invisibly across continents. Maps appear instantly. Entire libraries rest inside a device small enough to fit into one hand. To that earlier observer, the technology would seem almost magical. Not because the laws of physics had changed, but because the ideas required to build such a device had not yet entered human imagination. Electricity already existed. Radio waves already crossed space. Silicon already rested quietly inside rocks. The future was already present. Humanity simply had not yet learned how to see it. Perhaps the universe still holds countless wonders in exactly the same way. Some of the universe's greatest wonders may already exist, not hidden by distance, but by ideas humanity has not yet imagined. This possibility is both humbling and wonderfully exciting. When we think about undiscovered mysteries, we often picture distant galaxies lying beyond the reach of our telescopes, or planets orbiting stars too faint to observe. Distance certainly hides many secrets, but history suggests that perhaps an even greater barrier exists: the limits of imagination. Again and again, reality has surprised humanity, not because nature suddenly changed, but because our understanding finally did. Long before microscopes existed, countless invisible organisms filled every drop of water. People drank from rivers, walked through forests, healed wounds, fell ill. All while surrounded by microscopic life they could neither see nor imagine. The bacteria were never hiding. Human thought simply lacked the tools and the concepts to recognize them. The same happened with galaxies. For centuries, faint cloudy patches decorating the night sky appeared mysterious but ordinary. Only after better telescopes arrived did astronomers realize those soft smudges were entire galaxies containing billions of stars. The Andromeda Galaxy had always been there. It patiently waited for minds capable of recognizing what they were seeing. Perhaps reality is still patiently waiting today. Dark matter offers one intriguing example. Astronomers observe galaxies rotating too rapidly for visible matter alone to explain. Something invisible contributes enormous amounts of gravity. Its influence appears undeniable. Yet its true identity remains unknown. Perhaps future generations will regard dark matter the way we now regard electricity. Something once mysterious, eventually familiar. Not because the universe changed, because human imagination expanded. Dark energy presents an even deeper puzzle. Observations suggest that the expansion of the universe is accelerating. Something seems to be gently pushing galaxies farther apart over cosmic time. Scientists have measured its effects with remarkable precision. Yet its underlying nature remains one of modern cosmology's greatest unanswered questions. Imagine explaining dark energy to someone living 500 years ago. The language itself would make little sense. Now imagine concepts awaiting humanity 500 years from today. They may prove equally unimaginable to us. Perhaps tomorrow's physics already surrounds us. Quantum mechanics beautifully illustrates how unfamiliar reality can become. Particles behave like waves. Observation influences measurement. Entangled particles remain mysteriously connected across enormous distances. Even the pioneers who developed quantum theory often struggled to accept its implications. Nature was not behaving irrationally. It was behaving beyond ordinary intuition. Human imagination had to stretch before it could begin describing what experiments repeatedly revealed. Maybe today's deepest mysteries require another equally profound expansion of thought. Artificial intelligence offers a fascinating parallel. Only decades ago, machines capable of recognizing speech, generating language, composing music, or assisting scientific research belonged largely to speculative fiction. The physical ingredients already existed: silicon, electricity, mathematics, computation. Yet the combinations necessary to unlock entirely new capabilities had not fully emerged. The future quietly waited inside possibilities nobody had yet assembled. The universe may contain countless similar opportunities. Even life itself could challenge our imagination. For generations, scientists searched for organisms resembling familiar plants or animals. Today, many researchers consider much broader possibilities. Life based upon unfamiliar chemistries, microbial ecosystems beneath frozen oceans, organisms thriving around hydrothermal vents, perhaps even entirely different forms of complexity, unlike anything Earth has produced. If such life exists elsewhere, we may initially fail to recognize it, simply because our definitions remain too narrow. Sometimes discovery requires inventing new questions before new answers become visible. History repeatedly teaches this lesson. Isaac Newton could scarcely imagine quantum computing. Charles Darwin never knew DNA. Edwin Hubble could not observe the cosmic microwave background. Albert Einstein did not witness gravitational waves being directly detected. Each transformed humanity's understanding. Each, nevertheless, lived before later revolutions unfolded. Knowledge always remains incomplete, because reality continues revealing deeper layers. Perhaps future astronomers will laugh gently at some of today's assumptions. Not because present science is careless, but because every generation works within the boundaries of what it can currently imagine. There is something wonderfully comforting about that. We sometimes feel disappointed by unanswered questions. Why cannot we explain consciousness completely? Why does dark matter remain elusive? What happened before cosmic inflation? Yet perhaps unanswered questions are not evidence of failure, Perhaps they are evidence that humanity still stands near the beginning of an extraordinarily long journey. The greatest chapters may still wait ahead. Children often demonstrate this beautifully. They ask questions adults rarely consider. Can stars hear each other? Why does space have no ceiling? What lives inside black holes? Their curiosity sometimes ignores conventional boundaries. Most childish ideas prove incorrect. Yet occasionally, entirely new ways of thinking begin with questions that older minds overlooked. Imagination frequently arrives before evidence. Only later do careful observations determine which possibilities truly belong to reality. The universe seems remarkably patient with this process. Science itself depends upon imagination more than many people realize. Before experiments are performed, someone must first imagine that reality could behave differently than previously believed. Every telescope begins as an idea. Every spacecraft begins as a dream. Every equation begins as a possibility. Human imagination quietly reaches ahead while observation gradually follows behind. The future emerges through their partnership. Standing beneath the stars tonight, it becomes impossible not to wonder what invisible truths already surround us. Perhaps entirely new forces remain undiscovered. Perhaps space-time possesses properties beyond our current mathematics. Perhaps consciousness plays roles we have not yet learned to recognize. Perhaps civilizations elsewhere have already solved questions humanity has only begun asking. Or perhaps the greatest surprise will come from something so ordinary that we currently overlook it every day, just as earlier generations overlooked microbes, galaxies, radio waves, and quantum behavior. The cosmos has repeatedly demonstrated that reality often proves stranger and more beautiful than expectation. There is profound hope hidden inside that realization. It means the universe has not finished surprising us. Some future child may grow into the scientist who uncovers an entirely new principle of nature. Some unnoticed observation made today may become tomorrow's revolutionary insight. Some faint signal arriving from deep space may eventually transform our understanding of cosmic history. The future already whispers around us. We simply have not yet learned its language. Perhaps that is why the night sky never feels completely familiar. Even after centuries of observation, every constellation still carries unknown stories. Every distant galaxy preserves mysteries beyond today's imagination. Every photon reaching Earth may contain clues waiting for questions humanity has not yet learned to ask. And perhaps the greatest wonder of all is this: the tomorrow no telescope can yet see may already be quietly unfolding, not because it lies beyond the edge of the observable universe, but because it waits patiently beyond the present horizon of human thought, inviting future generations to imagine ideas so new that, once discovered, they will seem as natural and inevitable as gravity, galaxies, and starlight seem to us today. 16. The endless conversation between humanity and the cosmos. For thousands of years, we have looked toward the stars searching for answers. Yet, perhaps the greatest gift the universe has given us is not certainty, but an endless conversation that will continue long after every generation has passed. Thank you for sharing another peaceful voyage through the quiet mysteries of the cosmos. If these reflections help you relax, wonder, or gently drift toward sleep, don't forget to subscribe. Until our next journey, rest peacefully. And may the universe continue whispering new questions, new discoveries, and new dreams beneath every star-filled night. For as long as human beings have walked beneath the night sky, one habit has quietly followed us. We look up. Children do it instinctively. Travelers pause beneath unfamiliar constellations. Sailors once trusted the stars to guide them across dark oceans. Astronomers build ever larger telescopes, patiently reaching farther into space than any generation before them. Even on the busiest evenings, when city lights soften the heavens, there remains something almost irresistible about lifting our eyes toward the darkness above. It is a gesture older than civilization itself. For thousands of years, we have looked toward the stars searching for answers. Yet perhaps the greatest gift the universe has given us is not certainty, but an endless conversation that will continue long after every generation has passed. Perhaps conversations are the best way to understand the history of discovery. Most conversations are never about finding one final sentence. They continue because every answer naturally inspires another question. A friend tells a story, someone else remembers another. Ideas build upon ideas. Curiosity grows through listening as much as through speaking. The universe seems to communicate in much the same gentle way. Every time humanity learns something extraordinary, reality quietly responds by revealing another mystery waiting just beyond. The conversation never truly ends. It simply becomes richer. Thousands of years ago, ancient people wondered why stars moved across the sky. Today, we understand planetary motion, stellar evolution, gravity, nuclear fusion, and the expansion of the universe. Yet, those remarkable discoveries did not silence our questions. Instead, they transformed them. Now, we ask about dark matter, dark energy, quantum gravity, the origins of consciousness, the possibility of life elsewhere, the shape of space-time beyond the observable universe. Our vocabulary has changed. Our curiosity has not. Perhaps curiosity itself has always been the language through which humanity speaks with the cosmos. The universe rarely answers loudly. Instead, it whispers patiently. A faint spectrum of light reveals the atmosphere of a distant planet. Tiny ripples in space-time announce the collision of black holes billions of light years away. Ancient photons quietly arrive after journeys lasting almost the entire history of the cosmos. Reality speaks softly. Science has learned to listen carefully. Every telescope humanity has ever built resembles another ear turned gently toward the stars. Each becomes more sensitive than the last. Galileo's simple instrument revealed moons orbiting Jupiter. The great observatories of the 20th century measured expanding galaxies. Modern space telescopes now peer toward the earliest visible moments after the Big Bang itself. Future observatories will almost certainly reveal wonders we cannot yet imagine. Not because the universe changes its story, because our ability to hear it continues growing. Yet perhaps listening is only half the conversation. The other half belongs to us. Every question humanity asks carries something uniquely beautiful. The stars themselves never wonder what they are. Gravity never questions its own existence. Light never pauses to admire its astonishing journey across billions of years. Only conscious minds seem capable of transforming observation into meaning. When we ask, why does the universe exist? Something remarkable happens. Reality begins reflecting upon itself. That may be one of consciousness's quiet miracles. We are not separate from the cosmos attempting to study it from outside. We are one small part of it, becoming aware. The conversation becomes possible because both voices belong to the same ancient story. This relationship has slowly shaped civilization itself. Astronomy inspired calendars. Calendars guided agriculture. Navigation crossed oceans. Physics transformed technology. Space exploration united generations beneath shared dreams. Even art, poetry, music, and philosophy continually return to the stars. The night sky has never belonged only to scientists. It belongs equally to dreamers. Every civilization has looked upward and discovered something worth wondering about. Perhaps that is why the stars never seem to grow old. Each generation inherits exactly the same heavens. Yet every generation finds different questions waiting there. The Egyptians saw eternal order. The Polynesians found pathways across vast oceans. Galileo discovered moving worlds. Einstein found curved space-time. Modern astronomers see galaxies whose light began traveling before Earth even existed. Future generations will undoubtedly see still more. The sky remains constant. The conversation evolves. Imagine someone living 1,000 years from now, standing beneath a familiar constellation. The stars may appear almost unchanged, yet their understanding of the universe could be profoundly different from ours. Perhaps they will have visited nearby planetary systems. Perhaps they will understand dark matter. Perhaps entirely new branches of science will exist. They may smile kindly at today's unanswered questions, just as we smile at some uncertainties from centuries past. Yet even they will almost certainly continue asking new ones. Because every answer enlarges the landscape of mystery, there is something deeply comforting hidden within that thought. Human lives are wonderfully brief. Civilizations rise and fall. Languages change. Empires disappear. Even mountains slowly erode. Yet the conversation continues. One generation hands its questions to the next. Knowledge becomes inheritance. Curiosity becomes tradition. Wonder becomes one of humanity's oldest gifts, passed lovingly across time. Perhaps that continuity is more important than reaching final certainty. The universe has never promised complete answers. Instead, it offers something gentler: participation. Every person who studies the stars, reads about science, asks thoughtful questions, or simply pauses beneath the night sky joins a dialogue already billions of years old. No contribution is too small. A child's first question, an amateur astronomer's observation, a scientist's careful measurement, a philosopher's quiet reflection, each becomes another sentence added to humanity's ongoing conversation with the cosmos. Perhaps the universe values questions as much as answers. Questions keep us humble. They remind us that reality always exceeds imagination. They encourage cooperation across generations. Most importantly, they preserve wonder. Without unanswered questions, discovery would eventually fall silent. Instead, mystery keeps inviting us forward. Every horizon quietly promises another. Sleep itself offers an unexpected metaphor. Each evening we close our eyes without knowing exactly what dreams await. Morning always brings another opportunity to see the world anew. Humanity's relationship with the universe seems remarkably similar. Every generation awakens into a cosmos containing possibilities that previous generations could scarcely imagine. The adventure continues because tomorrow always arrives carrying unseen questions. Standing beneath the stars tonight, perhaps nothing has truly changed since our earliest ancestors first looked upward. The constellations remain. The moon continues crossing the sky. Galaxies still drift through the darkness. Yet something quietly grows with every passing century. Understanding, not complete understanding, never final understanding, but a conversation becoming steadily richer. More voices join, more stories intertwine, more mysteries reveal themselves. The universe never demands that we solve everything. It simply invites us to keep listening, to keep asking, to keep wondering. Perhaps that has always been enough. Perhaps the greatest achievement is not reaching the end of knowledge, but discovering that no end exists. The conversation itself becomes the destination, an endless exchange between ancient starlight and curious minds, between timeless natural laws and ever-changing generations of dreamers, between a universe that patiently reveals itself and humanity that patiently learns how to listen. Long after every one of us has become part of history, children not yet born will still stand beneath the same stars. They will ask new questions, build new telescopes, imagine new possibilities. The dialogue will continue, just as it always has. Not because certainty has finally been reached, but because wonder itself proves endlessly renewable. Every sunrise offers another chance to explore. Every night, sky opens another page. Every generation inherits both answers and mysteries in equal measure. And perhaps that delicate balance is the greatest gift the cosmos has ever offered. A conversation with no final chapter, where every ending quietly becomes another beginning, every discovery becomes another invitation, and every star-filled night gently reminds us that the universe has never stopped speaking to those willing to pause, look upward, and listen. Thank you for sharing another peaceful voyage through the quiet mysteries of the cosmos. If these reflections help you relax, wonder, or gently drift toward sleep, don't forget to subscribe. Until our next journey, rest peacefully. And may the universe continue whispering new questions, new discoveries, and new dreams beneath every star-filled night.